next time we meet to deal on the, I think tomorrow, yeah, tomorrow.
Yes,
we can deal on the foundation.
Foundation.
Yeah, but before then, we first of all design for the slab. Understand?
Okay, thank you so much.
Okay, yeah, that's fine. Okay.
You're really good. Thanks, Justice. I enjoyed the classroom. The class was excellent, very well put together, very, very clear. No, so I enjoyed it. No.
Oh yeah, thank you.
I wasn't able to get this far as how you explained it to me, no, because I didn't understand how to put the foundation and the first floor level. So all these are things that I enjoyed. I see that I'll try to model it. Okay, and then I'm going to see how I can add then the loads myself. But it's a similar building like this, no?
Okay, that's fine. That's okay. That's fine. Okay, that's fine. So we meet again tomorrow for the foundation and for the slab design.
Amen. Amen. Amen.
Okay,
all right. Yeah. Okay. All right. Well, you have a good evening,
you too.
Justice, and we'll meet tomorrow. No, thanks.
Okay. Yeah, that's fine. Okay. Yeah. Okay, so now for you to export a drawing to the software Protastructure, the first thing you do is to highlight the drawing you want to export. Highlight everything like this, and then type W, and enter. That W is like is a command that is used to save a drawing on a new drawing sheet or a new drawing area environment.
Windows. Yeah.
So with that, once you have done that white block, you then come and click on this icon here that has 3 dots inside it. This square icon, you click on it, and then you have to locate in a place in your computer where you want to save the drawing. So let me say I want to save it inside the desktop, inside desktop. So I will just click on my desktop there, and then I will then type the name. I'll type the name. So in this case, I want to use the name. And when you're saving the name, it is best you save it based on the project name, or you save it using the client's name. So for example, let me assume that I'm doing this design for Mr. John. So I'll just type Mr. John residential building. Residential building. Okay, building, know that. So now once you put in the file name, the next thing you have to do is to choose the file type, which is very, very important. AutoCAD uses 2 file formats to save drawing, either DWG or they use DSF. And when you're exporting a drawing from AutoCAD to the software Protastructure, it must be on DSF format. So I'll come now and choose DSF. Any of it is okay. So I'll come and choose DXF, and then I'll click on save, and I'll say okay. So with this now, if now minimize our listen and then go to the desktop, we'll be able to locate where that, yeah, you can see it here, Mr. John's residential building. Can you see that now? Hello, are you here?
Yes.
Okay, so with this now, we'll now open the software for our design. Let me know, what version do you have? 225, right?
Excuse me?
What version of the software do you have? 25?
The Prota?
Yes. Yes.
It's 25. Yes, it's 25.
Okay, so I'll open that now.
Okay.
I'll open it up now. Then hold on for it to open. Okay, is coming up. Okay, it's still opening.
Mhm.
Yeah. Okay. So once it comes up like this, the next thing to do is to click on new projects.
New project. Okay.
Yeah, new projects. Now, on that new project now, you see they'll ask you what's the project code, which simply means the project name. The same, you write the project name. So for example, we are doing Mr. John. So just click now. They don't allow you to like put a space. So you can put a underscore or you put a minus sign to add the next name. So I'll just say Mr. John. Yeah, Mr. John, let me say Mr. John Building. Mr. John Building Design. Okay, design. Yeah, that's fine. So now the next thing now to do is now choose your design code. You now scroll down here, scroll down, and then choose your design code and all that. So you can see that they have several codes here and all that. So you just come and choose the code that you want. So they have US code, IBC, metric, and imperial. So I'll come now and choose IBC metric.
Metric. Okay.
Then with that now, I'll then come and say okay. So by saying okay now, it will import all the code, all the code standards into this design environment now. So wait for it to load up. So yeah, so once this loads up now, and I know that, just to give you a clue about this design or modeling environment, this area here, this section is called the structure tree, right? Structure tree and all that. So you can see that everything you have here is under this place that says structure and all that. You have all these things here. Then you can see your modeling tab, building setup, loading tab, review, analysis, and all that. So as we go on, you will know how we have to use most of all these icons and all that, and the menu bars. So with that, now once you've come to this place, the first thing to do is to import that your GA drawing that you did. Is to import your GA drawing that you did. And how do we do that? We do that by coming to this place that says building setout here. Now, under this place now, we will see here that says external reference drawing. I'll then click on this place that says external reference drawing here and wait for a while. Then this, it will not display this dialog box. I'll then come and click here that says add DSF. Add DSF. I'll click on this place here. And then I have to locate the place where I saved again. Under my desktop, that's where I saved it before. And then I'll scroll down to locate that Mr. John's, you can see it here, Mr. John's residential building. So I'll click on this now and I'll say open. Now, once I've done that now, the next thing I'll do is to come, make sure I come here and say active. I'll check this active. I'll check it now. Then you can be able to see a trace now of your building plan is now showing here. This is a trace. Then, once you have done that, the next thing to do is now import those members, those your grid line and the column members that we set when we are doing our framing under this place here. So we now need to import this column as a column member and these grid lines as our grid axis. So with that now, then come and say import. You can see there, import DSF. So I'll click on this place now. And then they will ask me a question here, import grid, right, and import column. I'll say yes, just that too. And I'll come here and then click on import here. Now, you just give it some time, you start to bring or convert those columns to a column member. Now, once it is done, you see this place that says print log. That means that it is done. You can then come here and then say close. I'll come and say close now.
What is all the dialogue that's right beside it? No? When it said import, it had the window had a dialogue.
Okay, so yeah. So once we click here now, this import now, you see
tolerance.
DSF import. This internal box. DSF import. Understand?
This the settings is what?
No. You can leave these ones. You can set them later. You can set them later. These are just the beam length and all that. So you can leave these ones. Later we can be able to change it later. So just leave these ones as they are default. You can change them later. Yeah. So once you have done that and then click on import, then to be sure that that process is done, you see here I'll just show print log. Then once you see that, you can then come and say close. So I'll just cancel now. Yeah. Now you can see that now we now have our grid lines showing, and then we have our columns. Now, if you want to use the same color that you use, you can come here and say use color. You can see now it's not using the same color that you choose before. Can you see that?
Yes.
Okay, so I can choose to check it or leave it, but let me just check it. I will then come now and then click on OK. And then click on OK here. Now, once you've done that now, you can, now we are currently on the plan view. For us now navigate to 3D view, our plan view, you come under your tree here, you can see view here, view. Right click on the view, you will see 3D physical model. You click on that. You click on that. Then you can see this tab now will now be showing you here. Now you have plan view and then you have 3D. So you can choose to rotate by holding down your right click. You can see that here. Yeah. So this is now just the column and the grid lines alone that is showing. So now we'll now come back to our plan view. Now
how do you get the height? Like I see this is 3 meters. No?
Yeah. This height can be changed later after we are done with our modeling. We can need to change the height of the stories that we want. I will show you that later. So right now, I can leave it here first as the default height. Later, I can choose to change it to the height that we want, which I'll show you later. Then, so this is the 3D view now. Then coming back to this place now, to the plan view. Now, on the plan view now, before we will begin our putting our beams, concrete beams, you can see how the grid lines are being named, which is not the standard way of naming it. You can see A1, A2, and all that. Basically, you're meant to have grid line 1, 2, 3, and all that, right? And all that. So, but before we do that naming, there are some grid lines that are not giving any number. For example, this grid line 9, AA9, is not pointing out to any number. You can see that. That means that we have to take it off because it's not pointing to a column and there is no beam around this line. You can see that there's no wall line. So I'll just click on it and then delete. So I click on right click and then delete it. Okay, that's fine. I think that's all. That's only grid left. Yeah. So just look out for the grid that are not pointing at anything and then take it off. Now, once you've done that, now you can now choose to rename all these axes to be vertical ones to be 1, 2, 3, 4, 5. Why? Here can be A, B, and C on that. So to do that now, I'll go to this tab here, review tab. Under review tab now, I'll see that says what? Relabel members. Relabel members. So I'll click on this now, and then I'll say just on yes. This will not display. I want to rename just the what? Axis. So I'll come here and click on what? Check this axis here. And then I'll come here and they say axis direction. Direction 2 and direction 1. Now, direction 1 now is telling you, direction 1 is telling you axis going on the X direction like this. That's the one that is going what? Horizontal. My direction 2 is the vertical axis. So now I want vertical axis now to be 1 to 3 and not ABCD. And then direction 2, which is this one that is going what? Horizontal as ABCD. So once I've come here and pick this, I'll then come and say okay. Can see that they have all changed now. Can you see that?
Yep.
Okay, that's fine. So once you've done this now, the next thing is now begin our beam insertion, because now we only have our columns alone and just the columns and the grid line. So now come back to plan view here. on the plan view now, we'll now go to modeling tab. Modeling tab. On this modeling tab now, we have this concrete section area and the steel section. So you can see column here and column. This one here is for concrete and this is for steel.
Okay.
Steel. And we are dealing with now with concrete section. So now on this our model, we have the column. Now this wall you are seeing here is for a reinforced wall and not for block walls. It's for reinforced wall. So I will skip that and then move to beams. So on this beam now, if I click on the beam now, you see that they have two options, normal beam or wall coupling beam. We are dealing with what? Normal beams now, which are the floor beams. So I'll come here and click on what? Normal beam. That's normal. It will now display this dialog box for me and all that. Now, based on this place now, you have to add or type in the width of your beam and the depth of your beam. That's what we need here, and the width of the beam and the depth of the beam. Now, based on maybe your country standard and all that, you should have a minimum beam depth you use, or based on design code and all that. So in this case now, I think IBC uses 250 as a minimum. Although I don't know what you guys use in your country. But
yeah, between 8 inches, which would be around the 225 or less. No?
Okay. Yeah.
Right
so
now. It's
okay.
20.
Okay, that's 200, right?
200.
Okay,
or 225.
Okay, that's 225, right?
Mm-hmm.
Okay. Then the depth. What do you guys use for the depth?
The depth, the minimum that we is 250 or 300.
Okay, but no, you need to add the slab depth to it.
Oh, well then it would be an additional
150. That's like 450.
Yeah, about that 450.
Exactly.
Yeah.
So now, once you have added your width and your depth, when you want to insert, you might be seeing like a warning from the code that this that the section you're choosing is small. You can choose to ignore it after the design. If it's small, you can then choose to do what? Increase the size of the section. So on that now, I'll then click on the first column point here. Now, since we have our beam running from this column here to the last column here, I'll just click on the last column and then it will insert the beams, dividing it based on the column points. So I'll come here and then click at this one here. Then I'll hold on for a while for it to insert that. Now you can see the one in here. Just say don't show again, ignore it. It's not that the beam section width is too small, but leave it. During the design, it will show if it's small or not. So I'll just come here and say okay. Then you see that it will now insert the beams. You can see that I have beam 1, beam 2, and all that. Okay, so we'll just continue now. Now we already know how our beams are going to flow or run based on the GA that we did. Understand? So now we'll just follow what we have here by coming here now and then insert here again, from here all the way down here, and again from here all the way down here. Okay, and then let's see now, we have a beam running from here all the way down here, and again from here all the way down here, and again from here all the way down here, and again from here. So you can see the reason why you need to do your GA. You know, that will help you to know how you want to flow, how you want your beams to like connect and all that. And then I'll then come again now, escape now, then come again. This one is running from this beam to this beam, and then continue again from this beam to, okay, now, are you there? Just
yes.
note this. You can see that this beam here, which I'm about to like insert now, will be carried by the beam that is going on this direction.
Yes.
Now, before I insert this beam now, I must insert the main beam that will carry it. Else, okay, I'll be seeing it. It will be seeing it as if is a free end, cantilever end.
The cantilever,
Once
okay.
once you see this triangular sign, it means cantilever. So
Oh,
right
okay.
now, I'll just come and do what delete that by just clicking on what delete button, and then insert this one first, which is the main beam. Before I'll now come and insert this secondary beam here and add this. Okay, that's fine. So I'll then continue again. I'll add from here first to here to here. If I now come and add from here to here, okay. Again, I'll connect from here to here. That's fine. Okay. There, I think we have done. Yeah, we have done all the beams. So if I now go to my escape now and go to my 3D view, you can see that we have our beams now showing and all that. Correct. So I'll then come down and do what? Click on the model. Now, after our beam now, the next thing that we'll have is our concrete slab, which we are seeing here. Concrete slab. Now, before you must click or insert concrete slab, you'll be asked to define loading combinations and all that. So if I click on the concrete slab now, they will ask me a question, load case must be defined and all that. I'll say yes, define the load case. Now, once you have come to this load combination dialog box, you then come here that says loading generator. I'll click on this here, generator, and then you will see vertical loading combination and what? Horizontal load combination and all that. So right now, I'll go to the, now, if you're adding wind load to your structure or seismic load to your structure, that falls under horizontal load combination. Do you get? And all that. Now, so I'll come now and click on horizontal load combination. On this place, you can see your seismic loading is already checked. And then if you want to add wind load,
and if you don't have seismic, like in my country, no seismic, would you take it out?
Okay, yeah. So if you don't have seismic load, what you do is to cancel. Just watch. I'll cancel this first and cancel again. Just say no, then come back to settings here. This settings center, this tab here. I'll click on this settings here. Then it will open up the settings. I'll then come to codes. Right, you can see codes here. I'll come here and then click on this earthquake code. I'll click on it and then say don't use seismic code. So if I click, so yeah, so if I check this now, don't use, and I'll say pick. I'll say okay. If I come back to my loading, that same place we were before, let me just go again. You can see that seismic load now is no longer added.
Oh, okay.
Understand? Exactly.
All right.
So are we to add seismic load or that later?
Does that?
Are we to add seismic load to this structure or that will be later?
Yes, yes, correct.
So are we to add it?
Yes, let's add the wind load.
Okay, what about earthquake load?
No, we have more hurricane than earthquakes. Earthquakes, we have very minor earthquakes.
Okay, that's
like
fine.
The seismic, like
okay.
We rarely have above maybe 4.5, 3.2.
Yeah.
But it's more along the coast, no?
Okay, that's fine. That's okay. So with this now, we then come and click on what? Check wind load, and then always check this notional loading. Is there to correct for anything that is not perfect and all that. So it's there. Yeah, that's the factor of that. So now once you have checked this and this, that's all you need to check here. And then this vertical loading is already
you don't use it not cropped.
No, I don't use cross sections. I don't use So once you check these two, then for this vertical loading, don't check anything here, leave it in here as it is. Then if you have thermal, that's temperature, but I think that's scarce. It's not really in my country here, and I don't think you guys also have a very high temperature.
No.
Yeah, so once you've done that, you then come and click on what? Okay here. Okay, now you see your loading combinations now, and you can see that different load combinations have been added there. I'll then come now and then click on okay here. Okay, So with that now, you now see our slab dialog box now will now appear. So with this now, we then come here that says slab height, that's thickness, that's the height. I think in my own case, we use 150. In my country, that's
Yeah, 150.
Yeah, so I'll choose 150
So
there.
we typically use 127. That would be like the more typical.
That's
5 inches. That's 5 inches.
Okay, 127. Okay, that's okay. So you put your slab depth and then the concrete cover for the slab. What do you guys use for cover? In my own case, we use 25 here in my own country.
Yeah.
So what do you use? 25?
Yeah, same. 25.
Okay, 25. Okay, that's fine. Then you now come here under loads now. Loads. You can see loads here. You click on loads.
Yes.
So once you put in the depth and the concrete cover, leave this one first. This one here that says relative level is for if you have a different slab level. For example, let me say you're designing
like the verandas.
Yeah, auditorium hall, stadium that has different levels of seats of slab. That's why you can use this. Yeah, to not differentiate.
But what if you have like a veranda that has a like maybe 2 inches step down?
Exactly. Yeah, you can.
So that would be like 5 inches, like 50.
Exactly.
50,
so so you can use this now to now show the level that this one is going down by maybe 100 millimeter or 50 millimeter. Exactly. So you can be able to put the value here. It's about
especially when the hurricane comes, you don't want it to be at the same level as the door, because if not, then it starts to blow it in.
Okay. Yeah, so this is used to separate or to show difference in the slab level. That way you can use this level. Okay. Then you now come here now that says loads. Under loads now, on this loads, automatically once you put in your height, it will give you your self weight automatically. You can see that because the depth of the slab times the density of concrete will give you the self weight. So now you now come here that says dead load. Now you can see dead load here and your imposed load. You have dead load and imposed load now. Now on this dead load now, note that the value you are putting here is not a factored load. They are unfactored loads. Right? Unfactored loads. And for dead load, what makes up the dead load value is the finishing load and your partition load. So for example now, let me minimize this and I open up these nodes here. For example now, what gives you your dead load value of that is finishing load plus partition load. Can you hear me?
Yes.
Okay, yeah. And then finishing load basically ranges from 0.5 kN per meter square to 1.2. That is in my country here. And also partition load ranges from 0.5 to 1.0. So within this range,
this would be more like the gypsum board or the sheet rock, the drywall, no? Like if you have a drywall ceiling and tiles, how is it that the partition load and the finishing loads are the same? Say for example, if you're checking like ceramic flooring or tiles, and then you have your tile, you have your thin set, then you have your screed, plus the slab itself, no? And then underneath that, then you have your ceiling, which would be a drywall ceiling with pipes and all your electrical ducting and everything for. So would that be something that I should consider maybe calculating those loads, and or you think with this finishing loads you're more or less around that same?
Yeah. Now, so look at how it is now. So basically now, first of all, this is the range between finishing load and partition load. Now, all what you have said now falls under dead load. For example, you said plumbing, you said ceiling, you said some kind of cladding and electrical. Those, if you put them together, they fall under dead load. Understand? So for example, I know that those loads are not that heavy, except you're doing for HVACs. If it's for HVACs, all these bigger AC pipes and all that, HVACs, then you can choose to add more load to the dead load. You need to factor out that load and then add it. But for general, let me say, residential use purposes that don't require all those bigger HVAC pipes and all that, you can use within this range and all that.
All right.
So me, what I do, if I see that the building will have so many finishes, cladding and all that, what I do, I just pick the maximum, 1.2 finishes and 1.0 partition. That gives me 2.2 as a dead load. Do you get? But
yes.
But if I see that the building doesn't have much finishes and much cladding and all that, I can pick here 1.0, and then here I pick 0.5 or 0.75, and that gives me 1.75 as my load. Understand?
Okay.
So
right.
That's how I picked for that. So with that now, let me assume that this building here does not have much load. So I can say, okay, 1.0 and they all, let me say 1.2 and then 0.5. Okay. That gives me, so here now, let me say 1.2 here, 1.2 and then 0.5. That gives me 1.7, 1.7, yeah, 1.7. So 1.7 as my load, dead load. So I'll come now, minimize this, and then add here that says dead load 1.7. Okay. Now here that says imposed load, which is the live load, just right click there, you will see several loads based on the type of building you are designing for or the usage. So in this case now, we are designing for what? Residential purposes. So I'll come here and says residential building here, this one here, this is 1.92. So I'll come and choose this now. If you're doing for office building, you can see offices here, you can see for hospital and all that, different school classroom, you can see the different these things here, categories here. So I'll come now and pick okay.
What would be the difference between the residential private and the residential public?
Okay, you can see that here, it's a residential private now. For example, if you're designing for, you know, there are some countries that builds, for example, they can build 25-story building for renting. You understand? Just for renting, like for renting, all right? Apartments for like renting, and not for a personal use, not for private use and all that. Can you hear me?
Yes, yes.
Yeah, I said there are some people that build residential buildings, but it is there for just for renting, to like rent it out. You understand?
Yes.
So if it's not for personal use, if it's not for private use and all that, you can choose this one here that says public use, but it's still residential, because you don't know the kind of load those people that will be using that building, that what they will go and put there. They might go and put a gym, like all these gym this thing inside the room, right? Equipment.
I've seen them put a plastic water pools.
Exactly. So those kind of things, you understand? Yeah, so you don't know what they will use it for. So instead of not go and use 1.92, you have to use this because you don't know. But if it's your personal own, you know what you like the kind of thing they design it for. So you can make to work and use that. So with this, I will use this one here, assuming that it's for private use and all that. So I'll come and use this here. Then once you've done that now, you can see that here, rain load here is not active and all that. Rain load is not active, snow load is not active, roof load is not active and all that. But I think if you want to add it, I don't know if you guys add in your country, snow load and all that.
No.
Okay, yeah.
But rain load would be like what? Like what would count as rain load?
Okay, for example, yeah, although rain load is not that heavy, I think the maximum is 1.2. But rain load is if you have a very high, like rain effect. There are some rain that when it's falling, what falls is ice block used to force with it.
Oh, okay, like hail.
So yeah,
Hail.
those kind of rains are very heavy rain, like that comes with block. They're like heavy. So with that, if your country experience that, then you can add 1.2 as the rain load and all that. Although you cannot add it on the floor slab, that will be on the slab that are being exposed. For example,
or how if you have like a flat roof, almost flat, instead of giving it like the 30% pitch or the 15, you go less, like 2 or 3, whereby now the like if you're doing like a warehouse, then but you do one slope, a single slope, and then it's not that steep, no? So if the slope isn't that steep, then maybe you could think about maybe, because then the rain is going to take longer for it to
exactly. That's true. Yeah, that's true. So you can then add that. I think they used to activate it somewhere. You can I think maybe after I'll show you how to make it to like show that. Yeah, activate that. Okay, but apart from that, this is the load that you need and all that. This is the load that you need. Okay, then once you've done that now,
and then it says slab does not contribute to
yes
or diaphragm.
Yes, don't check it.
Okay,
don't check it. So once you have done these two now, the next thing now is to now begin to do what? Insert. So we already have our panels where our slabs are going to be placed. So I'm not going to do what? I'm going to click on each of the panels now. I'll click on them.
Okay.
Click on one of them. That's it. Then you need to click on the panels where
you right click, or you just
just and click on it. Just click on it. Click.
Okay, left click, no?
Yeah, left click, yes. So I'll click on it and then click this, click this, click this, click this, and then click, and then here. Now, for the staircase, leave it as default.
Okay.
So as open, because most times staircase have been designed separately. But on this next version that is coming out by next month, you'll be able to design model and then design staircase with it. So let me just show you that. Next year version will be coming out by next month. Actually next month. So you can see that we'll be able to model staircase with it. Let me just show you that. Okay, let me show you that. So this is 2026 version that is coming out next month. So you can see that the new thing that they added is to let me just go there right now. Yeah, can you see that? And I can make the model staircase.
Yes.
Yeah, can you see that? So you can make the model and then also design it with it alongside.
Oh, okay.
Yeah, that's for next day. That's for next day version, but
that's wonderful.
Yeah, okay. So with that now, let me go back here. So, but for now, leave it as default, as open. I'll then come now. Once you do with that, you can just choose to close. Now, if we now go to our 3D view now, you're able to see the slab now and all that. Okay. Now I'll then come back here to my slab. Now, before let me go again. If there is any cantilever on the building, let's see. If I have cantilever on the building, I doubt. Let me just check that again. Let me see that. Okay, there's no cantilever on the building. Yeah, no cantilever. But if we have a, let me say, if we had a cantilever, let me show you how to add cantilevers. Let me assume that we have a cantilever around this. Let me say this side. All right. To add a cantilever slab, can you hear me?
Yes.
Okay. To add a cantilever slab, what we do is to just the same way to click on your slab, define your depth. I think we use 127, and then the concrete cover 25, and then the loads we choose the 1.77, and then here we use this correct. Now, once you've done this, now come back to your general. And then you see that say type here.
Okay.
You click on this type 12 here, which is this last one here.
Oh, okay. All right. Cool.
Cantilever. So I'll click on it now, and then you see that you have a new tab here that says cantilever.
Oh, I see.
Now click on this tab. Now, before this, now you must have known your length, all right? Cantilever length. At what length is it going? So let me assume that we have a 750 cantilever length, or let me say 1 meter. That's 1,000.
1,000. Yeah, 1,000.
Then you ask the what cantilever load is what it is called here, parapet load. But this is the cantilever load. That's the load at the edge of the cantilever of the slab.
Like if you have a little veranda, no railing.
Yeah. Let me say handrail or something, or let me say there's a block. Let me say a block sitting there. For example, you can see this one here is a cantilever.
Yes.
So let me assume that there's a block sitting there. All you need to do was calculate the load of the block. For example, you can see it here. You can see block wall load, block load, and all that for 9 inches block wall. Then you can see the total load here. If you add plastering and everything, you have this.
Yes.
So you just to add the cantilever load. If it's a handrail and just the rail, and the rail is not that is a tubular pipes that doesn't have much weight. You can use 3.5 or even 1.5. Nice if it's not that tall. If it's not that tall, yeah, you can use that. Then you now come now. Once you define your load, define your cantilever length. To now add cantilever, we used to add it. You just click on the point where the thing starts from. I'll click. Let me say it starts from here, and then the last point. I'll then click on this place now, and then you can see specify either in or out. In this case, we are out. I'll then click on out here. You can see the cantilever here. If I now go to my 3D view now, you can see the cantilever here and the slab showing. So you got the load showing.
So already put places the load.
Exactly, yeah. So you can be able to see the load there. And if you also hover your hand over it, you can see load there. Load G is 3.5. Can you see there 3.5 per meter square under the list of this line load that is showing? Exactly. So you can be able to see it there. The load is showing there. Now, if you want to add load here, so for example, I want to add a load here on this side, because right now it's just showing the load on just one side, which is the longer end. If you want to add a load here, can you hear me?
Yes.
So if I want to add this same load now on this other side of the slab, all right, what I would do is to come here, although this one alone is already okay. But if I thought you want to add your own load, for example, you want to add a load on this line now,
yes,
and not on these lines too, what I will do now is to come to my loading here, and then I'll see line load. You can see here point load.
Okay, point loads, line loads.
I'll click on it now, and I'll click on line load, and then I'll come here. They say add the value. I'll come and put it under dead load 3.2. That's what you're using before. So I'll come when I put that value now. Now come and I'll click on this point, and then click on this last point here. You can see load now is not added. I'll come again here. I'll click this first point, and then the last point where the load to be added. You can see our load. If I go to my 3D view now, you can see load is not there. Can you see that?
Yes.
Correct. So that's how to add line load. You can just add line load using this method to add line load. So that's it.
But you don't have to go all the way to the middle of the column, no? Because
yes. Yeah. For example, let me say I want to add it from this point.
Yes.
And just to come like this now, and then line load, and then 3.2. Okay, then come here, click from this point. So just get the point, and then the next point again, and add it here.
Okay.
You can also see it here. It's also showing here. For example,
and then how do you erase or that erases the one that was before?
No. For example, now what you do is you come and first of all remove this one that's here before. Delete it.
You remove it first. Okay.
Yeah. So you just click on it, and then right click, and then you can see delete. Okay. Then come back and add a new load. For example, I can see add load while I'm still on this on this view. So I'll come now, click on the load, then line load, and then 3.2, which I want to use. Then locate this point, and then this other point, and add it. Can you see that?
Yes.
Okay, that's fine. So, but for now, we don't have this among our structures. So I'll just highlight and then remove it. But this has to add cantilever load, and also line load. If you want to add line load and delete it, you just come here, delete this, delete, delete. Okay, that's fine. So with this now, we are now back to this place. Now, before I insert story, because right now we have just modeled for this ground floor, which we have here. We have done the ground floor modeling, this ground floor here. Now I need to do what? Insert the upper floor. But before I do that, there is something I used to do on my end of beams, which is to hinge it. Most people don't use to hinge because most people don't use to hinge. Now, at default, this software takes everything as fixed end. All right, like all the ends of beam as fixed ends and all that. Which in my own case, I used to apply all the ends of the beam to be hinged. That's pin. Right? So can you hear me?
Can you repeat again? Just back.
Okay.
You were saying that you need to hinge.
Okay,
right,
that's
so,
fine. I said that once I'm done with my ground floor modeling, yeah, before I insert story, I used to hinge my ends of beam. All the ends of beam, I used to hinge it because this software used to give every end to be fixed, right? That's the default.
Before,
yeah, as fixed end. So as it is like this now, all the beams are being fixed or are having fixed ends and all that. So me, I used to apply pin ends, that's hinge end, to all the ends of my beams. For example, this beam one now has an end on this place.
Yes.
Right? And also this other beam here has an end at this place.
Yes.
So at this end now, I will assign as what? Hinge end. And also at this end also will be a hinge end. Why the other places here that is that has a continuous end, they'll be fixed. Understand?
So you can have moment redistribution, no? Moment distribution. Yeah.
Exactly. Yes, exactly. So with
this would be more like a continuous beam design, no?
Yes, exactly. Yeah, correct. So with that now, I will hinge all my ends of beam. And how do I do that? I'll click on the beam now. Let me say I want to hinge this beam now. And this beam has two ends, I end and J end. Can you see that? I and J. And now it is at the I end that is what? That is there's an end. Because at the J end, there's still a beam going forward, right?
Yes.
Continuous end. So with that now, I want to hinge the I end. So I'll click on the beam now. Right click, and then you see here, update beam end condition.
Oh, okay.
I'll come now and say hinge at left, which is I.
Oh, right, yes.
I'll come and click on it. I'll say yes, apply to select beam. Like I see that it's not showing 0.
Yes,
means that moment at this end now becomes 0. You understand? That's what this means. So with that now, I'll do the same now for the rest. Here also, if I come to this beam now, this beam here has an end at the J, but the I is not an end because there is still a beam which shows a continuous end. So I'll come to this beam now, click on it, and then right click and say update end condition and at J. I'll come here and say at J. I'll say update and apply. Okay. You can see it here. So with this now, I have free the moment around this place. Right?
So you lessen the negative moment at that
exactly.
Point, so it doesn't require that much steel.
At the top. Exactly. At this place. So again now, I'll do the same now for all the ends. So just to be fast with it, once you have known your I end and your J end, and you have known it very, very well, I can choose to do all at once by holding my control key on my keyboard and then begin to select all the ends that are I first. So with this now, I want to hinge. This beam here will be hinged at J, right? At J. So I'll click on it and hold my control key. And with that now, I'll select all the beam that will be hinged at J end, which is the right. Right? Is that right or up? So here also will be hinged. So I'll hold my control key and I'll click on this. This is also J end. Again, here I will hinge at J. Again, here I'll hinge at J. Again, this one is J, which is the right. Here also is right. Then let me see again. I think that's all. That's all. That's all. Yeah, that's all for now. I'll then come now, right click now and see update and control at J. It will hinge all the ones I've selected. Like you can get to see that now. This is hinge. This is also hinge, and this is also hinge. So now I'll then come again and now select all the I, and which is left or I. I'll come again now. This is left. I'll hold my control key and select this, and then select this one. Select this. Select this. Again, select this. Select this, and then select this. Then let me see again. Select this one. Okay. I'll then right click now, and then come here and select I end until update. Now, once you've done that, now we need to confirm all the ends if they have. Now, this one's now they are both ends because both ends are free, right? This one here. So I'll have to hold again and select all the ones that have both ends again. Both ends. This is both ends too. I'll then right click now and select. You can see it here, both ends. So I'll click here and say both ends now. I'll say apply. Okay, so this is now you can see that they are all both ends now. Now you can see that there are something that we missed. So now this is meant to be at J. So I'll click and say J and then update. Again, let me see again. Let me see if I miss any of them. Okay, so just, yeah, here also is also missed. So I'll come here, right click here. This is J end. So hinge at J. Yeah. So just look at and just find again very well and see if you're missing one. So now it is best.
So you could actually say that you free the ends for the secondary beams, no?
You say what?
You basically freeing the ends for secondary beams, no? So all the beams that join to the main beams, no? Like B and A. So all the horizontals you could classify them as main, no? And all the verticals which only span a short distance, you could classify them or think about them as secondary beams, no?
Okay.
No,
no.
Yes.
Look at what I'm hinging every ends of beam. Any beam any end that don't have that don't have anything like continuity of the beam, I will hinge there. For example, this beam now does not continue after this column. So that means that this is an end of beam. So I will hinge it. Because basically, when we are doing a design for a structure, one, we are looking for the stability and also for the cost. Now, this thing we have done now, which is hinging, we like have impact on the cost. So right now we have tried to reduce like the rebars we are meant to use at the top around this end has not been reduced. So what happened now is that since we have said that moment here should be 0, that's a hinge end, it means that it will just use a minimal reinforcement on that side. Understand?
But let me ask you this question: the same way like how you are hinging this, you're also removing the rigidity of the structure itself, because now it's more flexible, no? I mean, in the case of because you articulated the ends, no? So it doesn't have that the stiffness. You reduce the stiffness of the building, no?
Yeah,
it's a little bit more flexible.
That's what you're saying now. Yeah, that's what you're saying with ICON. If I'm designing for a building that will require earthquake or seismic load, I'll not apply hinge on it because I need the joint to be stiff.
Yes.
You understand? Exactly.
Yeah. Exactly. So when you're looking at torsional, when you're looking at global torsioning of the building itself, then you would need to contemplate whether or not the building itself is able or needs that rigidity. So in that case, maybe you would need to then again maybe pin it again so that it doesn't have the hinge ends. I'm just asking you.
Yeah, exactly. So when you are, let me say, for example, if the building will be having also related to either heavy loads, all right, external load, lateral loads, and all that will be coming in heavy loads. you might choose not to apply hinge, right? It will be left as fixed.
Mhm.
Understand? Because you like want those joints to be stiff and all that.
Correct.
But
Correct.
if it's just a minor building that does not require any lateral load or those kind of stuff, you can then choose to apply hinge at
Yes,
the end.
makes sense.
Exactly. Yeah.
Makes-
So you can see that so before you can insert story, you want make sure that you are done with everything, because once you insert, it's like copying what you have on the ground floor to the upper floor. When you can do what, make changes. But if you don't hinge it now, another insert, that means that you have to pass through this process twice.
Do the whole thing, yes.
Like one hinge the ground floor, first floor, and all that, which will take more longer time. So
Makes
make sure you are
sense.
done with all the changes you are meant to do. You understand? And everything. So you can do what, insert story. So with that now, you have done the hinging. Next thing is to do what, another insert our story and all
Okay.
that. So with that now, to now insert story, we have to come to under building setout here, tab, building setout here, then come to, you see here that says stories at the
Stories,
last
okay.
option. Click on the story, you see story operation, you click
Yes.
on this, and then you see insert story.
Inserts, okay.
So I'll come now and click on what, insert story here. Now they ask me to do what, number of story. So currently now we have story 1 alone. This is called story 1. So I'll come here, since this is a 1-story building, I'll come here and say 2. That is ground floor and the first floor. Right?
First floor.
Yeah. So I'll come now and do that. Now, if I want to generate story, that's to copy the column and the grid to the next floor, you must make sure you come and check here, generate story. Else, if you don't check this, it is only your grid line that will copy. For example, now, just but if I say okay now, I'll say yes. You can see what we have now is just the grid line.
Just the grid line.
We have story 2 now, but just the grid line, and which will not take a longer time to now going to be copying and all that. So what I'll do now is to, although you can still do it here by coming here, go back to story 1, highlight everything, and then say what, generate. But that will, it's the same process. So instead of doing that,
yes,
I'll just come back to this story 2, and then okay, I can still come here again under this place. Sorry, not that place. Under that insert story, you can see that says generate story. So had they been reading inserted the story, you can see generate story here. So it's just like a passing through different process. So instead of I can do all at once at this place.
Okay.
So with that, I'll come and say okay, generate story now, which you can see now. They say okay, I want to copy from story 1 to story 2. You can see source story and target story. So now but let me just pass through the main step. So I'll come back here now, delete this one, which this is story 2, which I just did before, that has nothing with it, only the grid line. I'll take it off by coming here, by clicking and then say what? Remove story. I'll say yes. So now we are left only this story 1. To now insert story, come to business setout here, come to stories here, story operation, and then insert. Then come here and type the number of story. If you have up to 5 stories, just come here and put 5 or something. Understand? I'll come here now and type 2. But this is just one floor. Ground floor is seen as story 1. So the next floor is seen as story 2.
Yes,
now let me come here and put what? And put here generate. Means that it will copy both the slab, the beam, and the column to the next floor. Now, for this story height, still leave it as default. I'll show you how to change this later.
Okay.
Then come and do what? Click on what? Okay. So with this, now you can see that we now have everything copied to this next floor. We have story 1 now, and then story 2.
Story 2.
3D view now, which is here. You can see that has story 2. But now, we now consider if we want to use concrete roof or roofing sheets for this steel, for the roof, at the roof. Understand? If you want to use roofing sheets, then you don't need to do what? Remove your slabs from the roof side. That's from the roof level. Because right now, on this story 2 level, this is the roof beam now. Right? Assuming that this is a one floor. This is the roof beam. So right now, if we want to use concrete slab, then we can choose to begin to do what? Reduce the load on the slab. Because for example, if this is a roof beam now, we don't need we don't need that imposed to be 1.92 again. At least we should have to do what? Reduce it. Because right now, there is no much thing happening here, except maybe you have a tank, or that tank that will sit on the roof. So at that place, they can now choose to do what? Apply area load, which is the tank load, right? That will carry water tank at the top there or something. So if you have any load, but if it's not a concrete roof, then we go and remove the slabs. So can just remove this. Right now, I am assuming that we are dealing with what? Roofing sheets and not slab roof, right? Not a concrete roof. So with that now, I'll then come to this. I'll make sure I'm on story 2 now. Come to story 2 here. Double click on it. It will now be on story 2. I'll then remove the concrete slabs on this story 2. And by doing that, I'll come here. You can choose by holding your control key and then begin to click on each of them. But this will take time if you have a very massive building, right? So just to be fast with it, come to this. Once you're on that story, on your story 2, can you hear me?
Yes.
So once you're on your story 2, come to slabs here and drop down this slab. You see all the list of slabs on that story 2 or on that story. Click on the first one, hold your control key, hold your shift key, and then click on the last one. It will pick all the slabs on that floor. Right? So with that now, can you hear me? So with that
yes,
now, right click now and then say delete. I'll say yes, delete. So with this now, what we are saying that we want to use roofing sheets. That's roofing sheet for this roof. Now that we have removed the slab from the roof, from the second floor, which is the roof beam now, we need to reduce the depth of the beam, because what makes beam depth is the slab load plus the beam. So right now that we have removed the slab of 150, we need to subtract it from the beam depth, which will now make the beam depth now for the roof to be what? 300.
Yes.
You understand? So with that now, we also reduce this beam depth at once. So I'll be doing them one by one. That will take time by coming here now and then say properties, and then come here and reduce by 300 and say 300 and say update. That will take time. You can see that now we have just reduced this now, but that will take time because there are so many. So we can do all at once by coming here under your story 2 now. Click on beam and then click on this arrow sign here, or just double on it. It will list down all the beams that you have on story 2. Click on the first one, hold your shift key, and click on the last one.
The last one, okay.
You see that? You can come and right click now and then say properties. It will display the table of all the beams. Can you see this now? All right. So with this now, you can see H here. H says the depth of the beam. So I'll click on the H here, not on any of them, on the H. That will highlight that will highlight all the beams, all the depths.
The column, the complete column.
Yes, correct. Yeah. So just come and highlight. You can click on the H here to pick all the depth on that column. Right? Yes. Then come here that says, you can see here, column wise edit that has this pencil icon and paper. Column wise edit. If I click on this now, it will ask me to put in my new depth. And come here and type it in, or come here and then choose it.
300.
Right? Yeah. So I'll come here and do what? Type 300, or come here and choose 300. And then say, okay, everything will change. Can you see that? They have all changed.
I see.
Then I can come and then do what? Say close. So you can see that they have all changed to 300. If I come now and put my mouse on it, you can be able to see that they say H 300. Okay, that's fine. So with this now, we have modeled here becomes the ground floor, and here becomes the first floor, and this is the roof. Then now, we then need to do what? Under your roof beam now, if you come to your story 2 now, you can choose to remove most of the beams. For example, this one here can be removed on the roof beam, just to save more cost, because we don't need this. You can choose to span our roofing wood, timbers or wood.
Yes, sir.
Yeah, so you can choose to delete this beam and then delete this one. We don't need that. Even this one too can still be deleted, because a wood can be able to span from here to here, understand? So you can choose to pick most of the beams that you don't need, that will contribute to the roofing, and then remove them. But although most people just choose to leave everything the same, but for me,
Okay.
I like to just remove them, like remove few that will not contribute to the support of the roof and all that. Okay, so once you've done that, the next thing now to do, if we come back to our 3D view now to do what? We need to insert the height, to choose the height of the ground floor and the first floor, because the height of the ground floor might be different from the height of the first floor. So now insert your height and all that, still under building set out here. Come to story here, which is the same place here, story operation, and then you see edit story. All right, edit story. Are you there?
Yes.
I'll click on this place now, edit story, and then you can see it here. Story 1, story 2, which is the H. You can see the height here. These are the heights. So let me assume that story 1, based on that, there will be some kind of activities that will be happening there, and on the ground floor, DPC, you know that. So let me assume that, for example, let me say story 1 should be 3,150 or 3,200 or let me say 3,300 or something, right? So you just put in your height of your story 1 and your story 2 here. Let me assume that story 2 is 3,150 and all that. Then your DPC. I don't know if you know what they call DPC. That's the first story button, the first story button level. DPC floor. No, I'm asking if you know what they call DPC floor, DPC level. Do you know?
Normally we require 32 inches, so it's like 900 above the ground level, no?
Okay, yeah, that's fine. Yeah. So also here too, so you can choose to add that value here. You understand? 900. But in my own case here, my country we use for normal building, all right? We use 450 for private building. Why for public structures like we use 600? You understand? Although but it all depends. So just
for us it's because of the hurricane. So because once a storm surge comes, it usually goes up about maybe 2.5 feet. So you don't want your buildings to be too low, no?
Oh, okay, that's fine. So then come in and then put the value here, 900 here. So you put it under the first, this place here.
Okay, all right.
You put it here, and then that's all. That's all for here. Later, when we're doing high-rise building, I'll show you how to apply this here that says impose load reduction.
Reduction, yeah.
Exactly, but not for this building. This is very, very small in the height to like do that. So I'll come now and click on what? Once I've done this height, and then I'll apply your DPC level. Now for this foundation depth, leave it as it is, because at site it might change. You understand? Because even if you add anything here, at site it might change, because they might be digging now and then find a clay. They will need to dig deeper or find a pit or something. So that's why
we usually do the soil testing, you know. So I will share with you a soil test that we recently did. And maybe it would be something interesting that you can maybe guide me.
Okay. Is it now? We'll share a screen now or later.
What's that? No. I'll send it to you, and then you can check it.
Okay. That's fine. Okay. So once you're putting your heights and everything, and then you put your DPC level and then foundation depth, you can leave it as default because it might change later. Then come here and then click on OK. And then say yes. So you can see that the like you can see that there's a small the thing just increases in height. So if you now check this, you can see the height now has now increased. 0.9, 4.2, and then 7 point this.
I see.
I see that? Exactly.
Yes.
Exactly.
Yes.
So
it automatically sent it up, no? It did the calculations.
Yeah. Yes, sure, exactly. So with this now, the next thing we'll do now is to add the wall load on this beam, because there's going to be a block wall load that will rest on this beam, right? Are you hear me?
Yes, I am.
Yeah, so we're going to add block wall load now on this our first floor beam, which is this first floor beam here. We'll add block wall load. So by doing that now, I'll then right click, just click on any of the beam, then right click, and then you will see it that says edit loads. Edit loads. I will then click on this here, then wait for a while to like display the dialog box will like display. Okay, now on this now we have several loads: point load, uniform load, partial, but we are dealing with what? Wall load.
Wall load.
So I'll come now and then click on what? Wall load. Now on doing that now, it will display this load what properties and all that. Now you need to define your wall unit weight, which I did there before, which I showed you here.
Yes.
You can see it here. It says weight of 9 inches block wall is 2.87. Then weight of what? Weight of plastering is 0.1. Sorry, 0.3. Now, total weight of one block now, knowing that there is no way you like build a building without having plastering left and right of the block. So you can see now total weight of block now becomes weight of block, which is one block, plus plastering on one side and plastering on the other side. That gives me 3.47. All right, as the block wall unit weight. That's for 9 inches block wall, 9-inch block wall. So you can, if you have any block load or block size in your country, you can figure out what is the unit weight first. Then now you cannot add a plastering load to the value. That gives you the weight of one block. That is unit weight of one block. Can you hear me?
Yes. For me, it would be a little bit different, but yes, about the same. You are at 3.47. We are at 2.5 because the blocks that we use are 6 and 8. No?
Yeah. What about plastering?
With plastering, the 6-inch blocks come up to 2.5. So you're at 9 inches and we're at 6. So that's the reason why. And then we are also taking into consideration the core fill, which I was telling you about. No?
Okay, that's fine. Okay, that's fine. Okay, so with that now, so you say is in 2 point what?
2.5. 2.5.
Okay, that's fine. So you now come now and then add it here. Wall unit weight 2.5. So I'll put 2.5. And then you can see they are asking you now what is the height. Now this height here is not basically the height of the story. It's the height where the block will occupy. Knowing that we have a beam already on above at this place, and this beam is what 300 millimeter, and the height that we took, we took 3.3. No, 3.115. 3.3 was for this other level here. So here was 3.15 that we took. So if we now subtract 3.15 minus this beam depth, because right now we are trying to give the actual space the block will occupy. So which will be under the beam surface of the roof beam to the top of the slab. I don't know if you get. So right now we now subtract the height of the story, which is 3150, minus 300, which is the beam depth. So this is the actual space that the block will occupy. I don't know if you understand what I mean.
Yes. So you're taking the total height minus the beam height, and that gives you the block height. So
yes, exactly. Okay, yeah. Exactly. So with this now, we now put this value. So this is 2850. So come now and put it here under the height here, 28550. That's fine. Now you then put the wall thickness. What's the wall thickness that you're using? That we take?
I was telling you
200, right? 200.
Yeah, well, 150.
Yeah, 150.
150 because no, it will be 200 with the plastering, no?
Yeah, 200. So now put in the slab and the block wall thickness 200 here. And once I've done this now, sorry, we didn't add this again. Let me put this 2.5 as the So once you have put all this now and all that, you then come here and click on this beam here. Just click on it. It will add the load to it. I'll click on it now. You can see the load now is now added. You can also see the see the reaction, all right, based on the beam self weight, that's beam on weight, and the load added to it. You then come now and then click on OK. So you'll be able to see that. You can see that the beam now is not showing the wall load there. Can you see that? You then come now, click on this load and copy it. I'll just copy, just click on it now. Right, click on it. Yeah, click on the one that has load now. Right, click on it and then say copy load.
Copy load.
You just say OK. You can see, just say OK. And then we want to add wall load now to all the beams. Then later we can be able to check the ones that don't have wall load. So now come now to now add the wall load now general to all the beams here on this floor. We can come back to story 1 where we have the load, which is this level. Then click on your beam here, drop it down by clicking on this arrow here, or just double click on this beam. You just drop it down. Then click on the first beam, hold your shift key, and click on the last beam. It will pick all the beams on that level. Yes. Then come out here, right click. You will see paste loads, right? Paste loads. Click on the paste loads. You can see there, all the load now is not being pasted here. Then go back to your CAD file, because there are some beams that don't require block wall load. So I'll come back to my CAD file now. Here, you can see that this beam here only requires handrail. There's a this thing you can see there. This thing, this is the handrail. Again, this also a handrail. Either opening or something. There's an opening there, space there. So here too it requires opening, and then at the back here too it requires. So this one's I can just do what, remove the loads on this ones. Although this one too that has between the lobby. So
the three of them, no?
Exactly. So this one, and then this. So I'll come now back to my it is here. So back to my model here, then go to my plan view story 1. Okay. Then I have, let me see again. I can choose to do it like this. This here, and then this here. Okay, that's fine. So I have this now. Let me see. That's the third one on this line. That's this one here. I'll click on it now, right click now, and then they what? Delete loads. I say delete loads. Again, that's off. Then come again here. This here now. It's that one here. I'll click here and say delete loads. Delete loads. Again here too. I also have this same thing here. Come again here. Delete loads. Delete loads. But though you can choose to leave it. That's the worst condition, right? But for me, if there is no load on the beam, I should just remove it. But most people choose to leave it. That's the worst condition that can happen. You understand? And all that. Yes. Okay. Again here, I'll come again here. It's that one now. Let me see here. That's this point here, and delete this load here. Delete this one here. Delete this. Again here, also have this here. Delete this. Delete. Delete. Okay. So with that now, I'm done with all my. You can see that now. So this one that have these hashed symbols have wall loads. Why the one with that hash has no wall load on, has no block wall load on it.
But you would need to add maybe the parapet.
Yeah. So we can just to add this handrail load. I know that. So I'll use a line load to add it. Line load. So I'll come back to loading now. Loading here, and then click on this here. Then click on line load here. This icon here. Then let me say the line load is not that much. The load of the handrail is not that much. I can choose 1.5 or 2.0. Say 2.0, and then I'll click on the face here of the column to the face of the column here. Again, I also have it here, face here to the face of this next column here. Again, at the back here, face here to the next face here. Again, at the front here, face to face here. Okay, that's fine. This here now is not the only loaded here because here is like a curve. It's like a curve.
Yes.
So I'll not add any load here. So with this now, come to my 3D view now. You can see what we have now. We have the loads now showing for that 100 and all that. Okay. So with this now I'll click on save. Now, I believe in your country, based on hurricane and all that, you might want to model the for like a Plinth beam. For a Plinth beam, for a Plinth beam. Are you hear me?
A Plinth beam.
Yeah. Yes, Plinth beam under this place.
So what we do, we actually put tiles, tile caps, and then we put the ground beams.
Okay. So with that now, because why I'm saying that, like if it's in my own country, you can choose to leave it this way. All the block works that will be on this ground floor can be resting directly on the DPC slab, which has direct contact with the soil already. So we don't factor that load.
Yes,
you understand? Yes. Because it has direct contact with the soil already. So the soil will like add to the supporting of the block wall load and all that.
Like a ground slab, no? Or
exactly.
Or a raft. No?
Yes. Ground slab. Although most people tend to add it. But for me, most times I choose to add it or not, except the soil of that place is very weak. That if the block load is resting on the soil, due to that the soil is weak, there will be some kind of settlement, uneven settlement, which will make the block like crack. So with that, I can choose to add a beam, Plinth beam that will carry the block. Can you hear me?
Yes, let's add it.
Okay, that's fine. So right now, for us to add that, I'll come out to my plan view here. Right now, most people tend to create a new story for that, but for me, I don't do that because if you do that, it will be seen it as a two-story floor, all right, two-story building. So what I do is to model the beam and then send it downward. So what I'll do now, the same thing now, which I've just done now, I'll come here, back to my modeling here, then click on my beam again, click on this. Now, first, you need to know the level. Now, the beam will be seen at the DPC level. So right now, our height of this story first is 3.3. That's 3.3 millimeters. That's 3.3 meters. So with that now, I want to send it down to that level, 3.3 meters. So it will be directly at the top, at the level of our DPC. I don't know if you get what I mean. That this will be. So okay. I'll come now back to my plan view here now. Click on my slab now. Sorry, on my beam. On my beam. Then click on normal beam. Then on this, the same. I can choose to use the same section.
Let's use the same.
Yeah. Then now I'll then come to my 3D. You can see 3D here. It's showing 3D model here. 3D tab. I'll click on this now. Now I now define the level of that beam. The level, which is this DZI and DZJ. So I'll come now and put minus, meaning that it should send the beam to minus 330, which is the level, like the last floor or the last level of that story.
Yes.
I'll come again here to minus 3300, and I'll come now and then insert. Just the same way you like normally insert beam. Click on this, and then I have the beam running all the way down to this level. I'll come again here and then click here. They will ask me a question to split. Reason because there is a beam already showing here. The beam coming. I'll say no, because if you say yes, it will divide the beam at this point, which is not nice. So I'll just say no, don't split. I'll say no, just click on no. I'll say no, don't split. So right now we now have two beams here. You can see that if we zoom in now, you can see that there are two tests. One is red and one is black.
Okay.
All right. But one of the beams is below. So if I come to my 3D model here, you can see it here.
I see.
Can you see that? Hello. Are you
Yes,
there?
I can see that. Yes.
Correct. So you can see that this thing now is now below. Yeah, so I'll use the same way now to insert for all other beams where I want to connect or have a plain beam. So I'll come again now. Again, the same thing, click on this beam, normal beam. Again, come here, set it minus 3000 going down. Sorry, 33, not 33 going down. Again, minus 3 going down. Okay, that's fine. So I'll come now and do the same thing from here all the way down. So just to trace how you have your beam before, or how you want to plumb it like B, or your grammar to be. So I'll come again now, click on this, go all the way down here, and click on this. Again, from here, all the way down here. And again, I want to have it here, from here to here. Again, from here, all the way down here, I'll say no, don't split. Again, I have a beam running from here to here. Okay, escape that. Again, let me say I have a beam running from here to just escape that first. Put the middle one first from here to this escape this two. Okay, yeah, to here. I'll say don't split. Okay, and let me put this one now. Escape from here to here. Okay, then from here now to these points. I said don't split, no. Again, let me see now. I now have, I'm going to put from here to here. Again, from this point to, so all the beams that will carry the block wall load at the lower level, just add your distance there. Again, now let me see, escape. We have to add this one from here to here. Okay. Let me see. I think everywhere is there. Let me just confirm if I have everything there. Let's see if I have everything. I just rotate like this to see that. Okay, I think we'll have all the beams now there at that lower level. Okay, so once you've done that now, yeah, we have all that. So just rotate back again. So now we can actually choose to add our wall load again on this level. All right, that's the block wall load. So again now, this level here is 3.3. That's the height of this level, 3.3 minus 450, which is our floor beam, which is here. That gives us, let me see that, 3300. Can you hear me? Minus 450.
Yes, yes.
That gives us 2.85 again. So I can just to copy this again, copy this, because since they are the same height, copy this, then come here, right click here, and then paste that load. Okay, that's fine. So you can see that it is still flushing under the beam. You can see that. Okay, so I'll do the same thing again now. To now do a multi-copy, pasting. Click on the first one, scroll down. Now, okay, sorry, you can't do that multi, because right now, if you do this now, you also select this beam here. So you can choose to hold your control key and select all the beams here that you have here. Okay, so I'll just do that now. Okay. Okay, that's all. Then here, okay, I'll then come now, right click now, and then say paste. Okay, that's fine. So we now have this now. Hello, are you with me? Okay, that's fine. So we have this now. Now I can choose to save first. Yeah, once you've modeled a bit, try and save in case maybe anything shuts down, you not lose what you've done. Hello, are you with me?
Yes, yes.
Okay, that's fine. So right now, I'll just do that now. Then, now we have done that. That means that we are done with our modeling with this. Yeah, you can choose to also apply hinge to these ones that you did here, or just leave it to this one here. That's hinging level and all that. This the same way we used to hinge. Now, let me say I want to hinge this end now. I'll click on this bin now, which is the J end. Right click now, the same thing, say hinge. Apply hinge at J, not that, just say yes, it will be there too. But let me just cancel, not that. Okay, so with this now, we have done the modeling for this bin. We have considered almost everything that we need to consider based on the building here, and also the loading and everything. We have done all that. So the next thing now is to now run the building analysis and all that. Okay. Now I don't know if you still have time, because I said no. I said 1 hour 30 minutes. So I don't know.
Yeah, we have time. Let's run the analysis.
Okay, that's fine. So with this now, I'll then come to analysis tab here, and then click on building analysis here. Okay, so with that now, I'll then come and first I have to come and choose my material, concrete grade, and then steel grade, and all that. So I'll come here and then choose. Now, before then, I believe we want to add wind load, right, to this structure. All right, wind load, right?
Yes.
Okay, that's fine. So right now, you know, the thing we did before was just to choose the wind load combination that we added it, but we have not actually added the wind speed and all that to this structure. So to now add your wind speed to the structure, it is found under loading here, loading tab. You'll be able to see your wind and story load here.
Oh. So
I'll click on this place now that says wind and story load. Then click on wind load calculator here that you have here. Then do not display the wind load parameter and all that. Now on this place now, based on the code we are using, there is the code required that we should choose what category or risk category. If you now click on this tab here to know what this thing means, on this caution sign here, you can see what that risk category means. It shows you buildings that falls based on different categories. Yeah. Now, category 1 now is saying building and other structures that represent a low risk to human lives. For example, if you're designing for like a warehouse that is meant to be used for farming purposes, where they'll be stacking cars, right, equipment and all that. That building does not require, like, it has very low risk to like human life. So that building falls under category 1. Understand? Then category 2 now is saying all buildings and other structures except those that is on category 1 and 3 and 4. Now category 3 now let's see what 3 and 4 says. Category 3 says building and other structures that if there's any failure will cause or pose a substantial risk to human life. For example, residential building falls under that. Understand? Because if anything happens, it will cause issues. For example, classroom structures, building and school buildings, yeah, falls under that. Then category 4 says building and other structures that let me say building and other structures that if it fails can cause hazard to communities. For example, if you're designing for like a pipeline, I don't know, there are pipelines, right? For example, pipelines, pedestals, like for pipe support, they'll be carrying oil pipelines and all that. If that thing fails and there'll be a spillage of what pipes, it might cause issues, because when an oil when a crude oil spills, it might take time for you to perform farming on that land. Understand? For like some years. That's 1. 2, if the building is if that structure will be used to, for example, to like stack farm grains, farm produce and all that. If that fails, it might cause famine because there will be a lack of food. So those kind of structures, right? For example, to water tanks that will be serving for the community to like go and like to store water and all that. If that kind of thing fails, it will cause issues. So those kind of stuff, understand, falls under this. understand, and all that. But based on our building, it falls under category 3.
Category 3.
Which is, yeah, 3. So I'll come now, just cancel this, and then come here and choose what category 3 here. Category 3. Now, here now, they are asking you what's your wind speed. You need to define your wind speed and all that.
Yeah,
so I don't know.
That would be like 60. Like
60, right?
Like 60.
Okay, 60. Yeah. So if you put 60 now, if you look at here, you can see the ultra result here, which is the wind pressure. You can see it here, 2.6 now, based on this value we just put now, which is the wind speed. Then you can see it here, wind directional factor and all that. If I click on this question sign here, you will see different type of structures and all that.
Oh, with the K factor, no?
You say what?
I'm just looking at the factor, the K factor.
Yes.
Yes.
Yeah, it's basically almost the same, except some this one is 0.9. You can see 0.9. Now you can see that this one that 0.9 that for what? Chimneys, tanks. So those kind of structures falls on, you can pick this. But apart from that, all the rest are 0.85. You can see that. Then you can see here two triangular trusses, but for this case, it falls under 0.85. So you can choose 0.85 as our what? As our factor for that, which is already here as at default. Then also for the gauge factor 2 and all that, gauge factor value ranges from 0.5 to 1.0 and all that. So for me, I can choose to use here 0.85 because this is like a factor that will add to the wind pressure. For example, if I come now, let me say I want to use 0.5 now, and all that. By the time we need to add choose our classes, exposure, class, and all that, you see that the value here will do what? Increase and all that. Let me just come in. Okay. So right now, let me just choose it as 0.85. I believe on the code too, you'll be able to see the range between gauge factor based on the locations or based on the cities. Understand? You'll be able to choose that. Okay. Then here that says minimum wind pressure and all that. You can choose any value, but not 0. You understand? Just at name minimum and all that. So the minimum wind pressure, maybe you guys have experienced in your city, you can choose that. So in this case now, the maximum we are choosing now is 2.65 as the wind pressure based on the wind speed we have here. So minimum wind pressure, you can pick any value, but not 0. Then primary wind wind angle now, knowing that wind can come from different angles, so it is not good to add any angle there. So to leave it at 0. Are you with me?
Yes.
Okay. Now, for here that says what? For building classes, you know that we have building based on different classes. We have open building, partially enclosed, and enclosed. For this case now, based on this building we are doing here, this is actually this is actually a closed building, right? An enclosed building. So the one that is an open building, for example, if you have a warehouse, a steel warehouse, or a steel shelter that don't have any kind of cladding on the side,
like an open auditorium where you play basketball.
Exactly. Yeah, exactly.
Like a shed.
Although if there are claddings, all right, if there are walls, all right, external walls around, you can choose that as a partially enclosed because there are windows, understand? But if all the external walls are just open all through, just the shelter and the extension that we have, that will be under, and that will be as an open building, understand, and all that. But for this case now, that we have everywhere blocked, right? Having block walls and all that, we can put that as what? An enclosed building.
Yeah.
Understand? Okay. Then for here now that says exposure category. If I click on this exposure category now, you will see they are showing different category now. Now, this simply means that, for example, if you are building, you can see the same category B, building with a mean height of so and so. Now, for example, what this just means is that if you know that every country or city has a place where buildings are highly populated and where they have less buildings and all that. Do you get, for example, countrysides where you don't have more high structures, you have almost everywhere bungalow and low-rise buildings and all that. So you have to now classify if your building is at a place where the other buildings that are already existing are a bit taller than your building. And for example, if you're building in countries like New York, and you're building a one-story building around New York, meaning that New York has a very tall buildings and tall structures. Your own one-story building now, when there is wind effect, you will see that your building will not have much wind effect on it because there are already tall buildings around that will be able to break the wind effect. I don't know if you get what I mean.
Yes, I understand.
Okay, that's fine. So in that case, so you have to come and pick them rightly or correctly. So category 1 says building with mean roof height less than 9.1 meters and surface up so and so up and all that. So then also exposure class C, all cases except B and D and all that. So in this case, I can choose category C. Okay, see now, you can see the picture of it, almost like a flat land that has building not close to each other, like spaced and all that. Category B was saying like a city, right, that has building packed to each other, like close to each other. Then category D is like a desert, you can see, and like a open field, open land. You understand? So in this case now, we can choose that, okay, it falls under a city. Let me say we are building in a city. Then we can choose that and then say, okay. Then, now, if I make any mistake and let me say I choose D now, you can see that the distance has increased. Pressure is now 5 point something. Because what it means is that at that D, which is a desert and let me say open field, open area, the wind effect on the stock will be very high. You understand? That's why you can see that the distance has not increased, the pressure has increased to 5.1. Are you with me?
Yes.
Okay, so in this case now, let me assume that it is on, like, it's built in a city. So I'll choose category B and then say, okay. So you can see that we have less wind pressure now, which is normal based on the load on this speed. Then also, surface roughness is almost the same with what I just explained on this category. But if I click here now, roughness, you can see surface roughness B is saying urban and sub area, right? And all that, which is almost the same thing as where you have like a city. If I take category C, you can see that it changes. This is like the countryside where you have grasses, but like trees and all that, yeah. Then category C is like a desert. There is no tree, and then you are around the coastal area, around the coastal region, just like a flat land. You understand? And all that. So you can choose that. So anything you choose here will also affect the wind pressure, because if it's in a flat land, there will be much wind attack on your structure and all that. So let me assume again that this building is to be built in an urban area, that's in the city. So I'll come here and then say what, click on what, okay. So if I also come now and then choose a different thing, let me say category D, this is MT, you can then, but what you choose here will also affect what you choose here on this exposure class B. Because you can't choose B that is in a city and then come and choose that the rough area is in a desert.
Yeah, makes sense, yeah.
So that's what it means. Okay, again now, let me choose now. So once you have done that now, the next thing now is going to understand this hue height and these values here. Now, you can get this based on this picture you're seeing here. This picture you are seeing here. Now, what it means is that, for example, if our building, for example, I think in your country, you say you guys used to have hurricane a lot.
Yes.
A lot. Although in my own country here that we don't have much wind effect, but there are some cities that used to have some wind effect, but not like a hurricane. So what they do is that after they are done building, if there is no tall structures or tall buildings around that city, or sorry, around the building, what we advise is that, okay, you can choose to plant trees, all right, trees a bit far away from the building, so that those trees will have to break wind effect. But in your country where you have hurricane, you can't advise to like plant, because hurricane can bring down a tree. You understand?
Yeah, that's right.
So you cannot advise that, because if a tree falls now, it can fall on your building. So you can't advise that. But that's what this thing is saying. It's trying to explain what is the distance of obstacle, like trees or tall buildings. What's the distance between the obstacle and the site where you want to build this your structure and all that. That's what
like 10 meters.
Exactly. That's what these things are saying. Then if you're building in a mountain area and all that too, you can then specify what the hill height, that's the mountain height and all that. You understand? That's what this means. Because if your building is found, let me say you have a mountain, like a hill, a mountain, and your building now is found at the lower side of the mountain. What it means is that you will be having more of downward wind. You understand? Downward wind. Because by the time the wind hits at the peak of the mountain, it will do what? It will have to divert down and all that. So that's what they are like asking you here. Then if your building is at, let me say, is at the peak of the mountain, or let me say, as you're seeing it here now, you can see that this building here is higher than the mountain. So if there's a wind now and all that, when it hits on the mountain, this building will be like, it will be having both upward wind and downward wind. Will be
yes,
in sun and all that. So you need to understand what's happening there and all that. But you can also choose to ignore this, then come to this place that says topographic factor. If I pick this now, everything here will be what? Ignored and all that. Now, based on codes and all that, you be able to see it under BS code based on the cities. For example, US code have some cities that you see that they will have their own factor based on their what? Based on how that area of that city is, topography and all that. You understand? But if you don't have this, then you can just don't check it and then just understand what I just explained here now.
Right.
So that's what this is saying and all that. So in my own country here, based on we don't have much of that, you just leave them as default. And I believe in your country, you don't have more of mountains and all that.
Yes. No.
Yeah,
no,
so you can leave all these ones as it is and all that.
All right.
Exactly. Then also this for this shape and all that, leave it as ridge and valley and all
Yes,
that.
okay. Yes.
Then also here too, upward crest and all that. So
Yeah,
also,
we're at sea level and it's flat lands.
yeah, okay.
Mountain, no?
Exactly. So you can leave these ones now at default and all that. Then once you have done this now, you can then choose to come here and then create a report for it. You create a report, just click on report. You hold on for it to generate the report for the wind and all that. Wait for that. Then you can see the wind reports here. You can choose to save it as DSF or Word and all that. Then once you've done that, you can choose to close that. Then now do apply. Now click on apply. Now once you apply it now, if you click on this plus sign, you can see each of the story now has a plus sign. By clicking, I can be able to see the wind pressure. Understand? And all they can see the wind.
All right. Yes.
FY and all that, yeah, for each of the story. So I'll close this one and then open story 2. You can see it here too, and all that. Okay. Now come and do what? Click here and then click on what? Okay. So right now, then click on save. We have applied wind load of what? Wind pressure of 2.65 pressure on this structure. Okay. So now come and do what? Click on what? This place that says what? Analysis tab here. Then now come here now. Under building analysis here. Then now come and do what? Click on what? Edit material. For us to choose our concrete grade and our steel grade. Then come in and click on what? Concrete grade here. Sorry, edit material there. Now this is our concrete grade and these are what? Rebar or steel grade. So I'll come in and click on any of them here. Any of them. I'll click on this one here, which is the concrete grade now. Now you need to choose your grade of concrete. What do you guys use in your country?
282 240, 280.
240, 240, that's fine, 240. Then you can choose to apply to all members. That's to boom and also column to all members. And then come and do a click on what OK. So
What you guys use in your country?
Okay, in my own country, what we use is 410, 460.
Okay.
410, 460, yes. So you can choose that now and then apply and then say OK. So once I've done now, although if you look at your own now, let me open that again. You can, if you click here, you can choose to see the strength here. You can see that 24. Can I see that there?
Okay. You know what? No, it's the equivalent of 3,500 psi. So that's probably going to right now. So
that'll be what?
3.5 psi convert.
Yeah, so convert it to like this. What do you have?
Right now.
Is it what?
It's 24 kilonewtons, so it's gonna be
24, right? That's
yes. Yes, that's that.
Yeah, that's it. So I'll come and then say okay. Then now this is the rebar strength or So I'll come now grade and then click on inner them again here, and then you can see different grade here. But look at this place here. This is the strength here. So you can see anything that you click is showing the strength.
Yeah, we have 16.
In my country, we use. Okay, sorry. You asked me before in my country what we use on our concrete. On our concrete, we use we use 25. Yeah, 25 minimum, 25 as our own concrete. Yeah, concrete 25 minimum. Then why for our steel, right? Reinforcement, we use 410, 460. Yes. So you can see the strength here for this.
Yeah, 60. We use 60.
Okay, that's fine. So now come and also choose here too to apply to all members. And then now don't just say okay. Now come and you can see that says edit rebar diameter. Edit. So you can come and then choose the size of your reinforcement for column, for beam. You can just assume it first. So now I come and click here that says what edit here. Click here, edit. Then on this place, you can see that we have this icon here that says column, wall, beam, slab, and all that. Now you can see the value, the bar diameters here are being shown here. Now in my own country here, minimum diameter of bar that we use for column is 16.
Okay, for us,
I don't know in your country.
5/8, which would be 15, 16.
16, right? Okay.
Yeah.
So in my own case, yeah, we use 16. Yeah, although we don't just choose 16, we need to choose like 2 or yeah. So we check okay, 16. And then in this case, okay.
Okay. So in this case, if I had chosen the US Imperial, it would have given me the 3/8, the
inches,
the half inch, the 5/8. Okay.
Exactly. Yes. Correct. Yeah, correct.
All right.
Yeah, correct. So right now, we then come here now, and then so we need to use 16, and then if there's any failure, let me say if it's not sufficient, you can click on 20. So I'll check 22, but I'll not check this one. But if it's for high-rise building, I can choose to check 25 and understand, and then
that's too much.
It's 2. But for this structure, it is too small. So I'll just take 16 and 20. Not that. Then also I'll then move to we don't have a reinforced wall here, so I'll leave this and then move to beam. Also the same thing too for beam. We used to use 16 and 20. So 16 and 20. I'll just uncheck these 2. Then I'll move to slab. Slab, we used to use 12. I don't know your country, which one do you use in your country? We used to use 12.
Right now, we more use the right now I'll tell you. More we use the 10. 10.
Okay.
And then if it jumps, jumps, then we use right now I'll tell you. If it jumps, then we use 13.
Okay, 13. Okay, so right now you can see that you don't have 13 here, but you can just add it.
14, yeah.
No.
But
if you don't have a bar here, can choose to add it by yourself. So you can see that there's an add button here, add.
Oh, all right.
You can choose, you can come now and come and say, okay, add. I'll come and then change what? I'll put as 13, and then here too, 13, and then put the area of that 13 now.
Yes.
That will give me, let me set in pi d square. So just let me just get that. Let me just get that and see. Pi d square, I think over pi d square. So let me say 3 d first is 13 times 13. Then pi d square over 4. Yeah, I think that's the formula. Pi d square over 4 or something.
Okay, but let's not waste time with that. I get what you're saying. So I could add that.
Yeah, so you just add the value here, the dark area here. Let me say it's 150 or something, right? They can actually add it. They now come and pick it. So it will be you have to use it now on your design. Understand? So this has to add any bar that you don't have. Okay, so but let me just come and then delete it in this case. Okay, that's fine. So right now, let me just say I add 14, right, to the slab, and then remove these other ones here. So now we have 10. Then if it jumps, it takes 14. Okay. Then now this one now is a rib slab. We don't have it on this piece, so I'll just leave it. Ignore it. This is for footing foundation. Okay. Now since we are using a pi foundation, right? I can choose to leave it, because this is for a pad footing. So I'll skip this one. Then go to links. Our being used to have links. So in my country here, we used to use link data to be 8 or 10. So I don't know what you guys use in your country. So I will check this one that are big. I'll check this one first.
For which one is it?
For links.
Oh, okay. Stirrups. The stirrups.
Yeah, stirrups.
Half inch and 3/8. So it would be the 12 and the 10 and the 12.7.
Okay, so let me just say 10 and 12. Okay, yes. So I'll choose 10 now and also 12 here. That's fine. Then I'll just uncheck the rest. Then these ones here are for walls, reinforced walls. All right, those are sidebars for walls. So just ignore it for now because we don't have it on this structure walls. Okay, so right now just come and say okay.
But those would be like for pool walls, for water tanks.
Yes. No, these are for concrete walls, like reinforced walls, shear walls.
That's right. Oh, okay, not for pools or for water tanks.
Yes. For pools, anything that is of reinforced concrete wall that you're going to encast the wall, right? Yeah, that's
shear walls. So.
Yes, shear walls for pool walls or shear walls, like for lift walls, for like lift shear walls and that. So yes, like yeah, that falls on that here.
So walls, huh? For the elevator shaft.
Exactly. Yes, exactly. So I'll come and then say okay here. Now, if you look at this place now that says type, that you can see that here is a rebar symbol. I don't know what you guys use for your rebar symbols, but in my country,
same.
Okay, diameter.
Diameter.
Right? Is it the diameter or what?
What's that?
Like this. Look, in my country here, see what we use. For example, now I'm doing a tilling for a building. Let me just show you what we use here. So we use either T. We use T for our own. You can see it. Let me just show you. So this is a reinforced what I'm like doing.
You need to.
We use T. As our symbol.
Okay. No. We use the little symbol.
Okay.
We don't do it like that. That's more like like the British standards
diameter.
So okay. We do D.
Okay, D. Is it D? Like D. Let me see. Let me just
like
show you.
D from diameter, yeah.
Okay, like D like this, right?
Yes.
Oh, okay. So right now, yeah, because this is why I asked so that you can make to add it. So right now, because I know Canada uses M as their own value. So right now I can come here and say rebar symbol. You come here and then put your value D.
Okay.
I see that? Yeah. So you can change it to like D. Then here that says that's the rod type. You know that we have several rods, like we have smooth rod and all that.
It's corrugated.
Exactly. So that's in type 2. That's type 2. That's a deformed rebar.
Yeah, corrugated.
All right. So once you have chosen all that, then come here and then say OK, and then everything will change, and then say final OK here, and then move to what? Now move to this tab here, analysis tab. Leave everything here as default for now. Everything here as default. Then move to analysis tab. Now, although most times you can see that says rigid zone. Most times people choose 25% as the rigid zone. Most times they still pick none.
Okay.
You understand? I know that. So move to analysis here, analysis tab here. Then once you come here now, you can come and click on what? Building analysis here. And then you hold on for a while for you to display that. Now you can choose to perform the two at once, design and both what analysis together. Now, if I check this now, if I check this and this, I'm saying that it should do what? It should design. But if I don't check it and then say start, like building this in analysis, what I'm doing is just what I'm only running what the building analysis without the design. Do you get? So right now I can choose to do all at once. I'll come here and say check design, check this, and also a select bar. So now I'm saying that if the 16 that we chose before for the minimum is not sufficient, it will jump to the higher one. That's what I'm doing here now by checking this. What is done? It's select bar join design. Okay, so once I check this for stuff now, I'll then come and do what? Click on here that says what? Building analysis here. I'll then wait for it to now begin. So I would like to finish up. Okay. Okay, it's coming up. Okay. Almost done. So right now is doing the column designs. Then once this is done, it will move to the beam design. Okay, so right now it's nothing the beam design now. Okay. Still coming up. Still coming up. It's coming up. Okay, it's coming up. It's coming up. Okay, it's still running for the beam design.
Mm-hmm.
Yeah.
And so this beam design, so it automatically puts it on all the four. Even if you had a roof, you don't have to.
Yes. It will design for all the stories, all the floors.
And it would automatically angle it with the roof, because
Yes,
you would have.
Yes, it does that.
So you don't need to like create a specific load on the roof so that it could then show it how it is, because the thing is that you have with a roof you have the two angles, no? So when it blows this side, it sucks on this side, no? So Protastructure already understands the suction and the well, a positive and a negative pressures that are created on the roof. Does it automatically do that?
Okay, let me, so I will come to that. So right now, once you've done your building analysis, you must see that this is this place must be showing okay, right? Satisfied. These two. Because when it's failing, when this is failing, right, which is the torrid drift is failing, it means that the load acting on the structure is a more compared to the weight of the structure or to the mass of the structure. And once that happens, that means that you tend to increase your like your sections of your vertical members. But in this case, it is not failing. I don't know if you get what I mean.
Yes, I understand what you mean. I was just
Okay.
wondering in terms of the roof itself, like when you model a roof, that it automatically compensates.
Yes. Once you model for the roof, automatically it just transfer the load to the roof. No need to add any load again on the on the roof beam. It will just transfer the load to the roof beams, and then continue from there.
No, but does it analyze then the truss then?
Yes, it does that. So now, in that case now, if you're using a steel, then you need to do a check your steel design. So first I'll just say okay first. Now, that means that when you're coming to this place here, before you come here, as you come here now, you need to check this steel also. Understand? This one here, this steel design. Do you get? That is, yeah. So if you have a steel truss mounted on this building now, you need to also check for this steel so that it's also designed for the steel alongside.
All right.
Exactly. So let me just cancel now and then close. So in this case, you can see that this is not ticked. That we have done what we have performed the building design for this building and all that. Then to now see the members that are failing and the ones that are having issues, you come to this place that says what? Display. On our display tab now, you will see that says what? Visual interrogation. Then click on this place here. And then you then scroll down to design. You can see design here. Then click on design status. You click on this now and then say okay. So you can see first, you can see that under this chart now, all this color coding here, red means failure, yellow means warning, orange means expert analysis, green means okay, and so on and so forth. So right now, white means design. We have not yet designed for the slab, but we have done what we have already performed the slab work, and we've already transferred the load to the beams, but we did not design for the slab to like know the reinforcement for it. That's why you can see that it is showing white. White means not designed.
Not designed.
Exactly. So you can see that most of our beams here are failing. For example, here is failing. This beam here is failing, and then the column also. One column here is failing. Yeah. You can see that it's failing. Exactly. So although even if they are all showing green, you still need to check the software to check what kind of reinforcement that was used. Do you get? And all that. So you need to check everything again, check everything to check the ones that are green, the ones that are yellow, and anything to check again. Make sure you check all the members to be sure of the reinforcement that you're having and all that.
Okay.
But let me start with this. Okay, let me start with this one that is that's failing here.
Failing.
I'll click on this now. Right click here and then say now come and click here, session design. I'll click on this now and then wait for it to open up. Now I just say yes, update. Now it's failing based on, you can see here based on depth. They are saying that based on code, right? If you don't check, minimum depth here should be 344, right? That's let's say 350, right? But we are using 300. Can you see that?
Yes.
So that's what is failing it. It's failing based on what? Deflection and all that. So it is either we increase the depth, although most times you can choose to use
bigger size
reinforcement,
bar.
yeah, to like control the deflection, but most times too is not also that advisable. You just to use the depth to like control that. So this is not, let me just back to 2016. Reduce this back to this. So now, for it to now apply the, like I said, this depth is failing. I know that. So you can come here now, under this bin, or come here. See there isn't this new version. Click on this place here, under this depth now, and then type in the new depth here by just highlighting here. And type, let's say 350 now, and press enter key. All right? Then now increase your bar to take this new depth. Increase and then decrease. If I increase now, you can see that, then decrease. It's now okay. Because right now we are having 350 is less than our depth. Sorry, 344 is less than the depth we are like doing what? Giving out, right? Providing. Can you see that?
Yes.
Okay. Then can just also update this and update this make it bigger, move this like this, update this too, that's fine. And just to increase it to, let me say 150 if you want, let me say 150, then 150, decrease this. Okay, you can always do by this. Okay, this here is already failing, so just update, then update flowing design principle, update. Okay, that's fine. So this is the links. So now this is the links. You can see there are links here.
Yes, sir.
Then this is the top bar. You can see top bar here is 2D 16. And then this is the bottom bar. You can see bottom bar here.
Oh, I see.
16. Now, if you want to add additional bar, for example, this top bar can still have additional, or bottom bar can still have additional bar. For example, if maybe this building was very, very massive and this building having heavy load, and we have increased up to 4 numbers, right? Just to avoid it not to be too tight, like the read bars, right? You can have a new layer at the bottom. And I don't know if you know that. So you can add a layer here now, a layer here, and come here and call it layer 2, which is already here, layer 2, and then make it to lap. So if I show the drawing now, let me say update again, updates. So if I show the drawing now of this, you can see what I have here. Let me just show you the drawing of that. You can see what now we have 6 numbers at the bottom, which is first layer 4, second layer 2. So this is what we have.
Yes.
Can you see that now?
Mm-hmm. Yep.
Yeah. So this is what that thing means. But in this case, we don't need these layers for bars because that too was already sufficient. Now also, you can see that when I increase this to like 4, here was showing red. Now, basically, on no account we anywhere show red, except this place here can show red, but only if the value that is showing red is either 20 or more than 20. The reason why is, so if it's 20 or above 20 and it's showing red, you can just allow it to be that these 2 values here, that's the spacing. And what does this thing means? What this spacing means is that, for example, if I now have 4 now, I have 4, or let me say I also have 4 here at the top here. They are both showing red. And I just to allow it because it is this value that is showing red is still more than 4. Sorry, it's still more than 20, right? 20 millimeter. Now, why is that? If I open my drawing now, that spacing that you're seeing there, what it means is the spacing between these 2 reinforcements. So if the spacing is less than 20 millimeter, what it means is that it will be hard for concrete to like pass through.
Yes.
Knowing that the maximum size of concrete chippings is what 20 millimeter. That's what I think 3/8 or something, or 3/4.
Yeah, it's 3/4.
Yeah, 3/4. So it means that if it is less than 20,
20 millimeter.
that concrete stone, all right, cannot be able to pass through this spacing of reinforcement. Except you have to use machine
vibrators.
Exactly, to vibrate in that. But in but just to avoid that, because most times you might not be at site when that will happen. So just to avoid that issue, make sure that your spacing between reinforcement here, this spacing here, is at least 20 and above, so that at least concrete can pass through freely.
Yes.
And all that without any issue. Correct. So so in this case now, if let me assume that it was 5 numbers that was able to like pass this, and here is showing 11, which is very low. What I'll do now, since this button says it will need 5 to like pass, all right, for it to be okay, I'll make it to be what, 3, and then step down 2. I'll step 2 down.
Oh, okay, all right.
You understand? So it's still 5. So yeah, so this is how to do that. So, but let me just remove this and then say.
I understand that.
Okay, that's fine. So with this now, let me just reduce that to 2. Okay. And then now, once everything is okay here, I'll then say okay. Now, note that since we increased this depth here manually and all that, when I say okay, since we have made changes that have altered what we did before, what we like designed before, it will tend to show what expired, what like it will tell that what you did before have what expired. So if I come down and say okay, you can see there, I think that we have made changes on our section that the building analysis will like cancel. If I say yes now, it will show what expired what analysis. Everything here will be showing what orange color. So I'll say yes, because I want to like take the new changes. If I say yes now, it will take the new changes now, and the bin now will be actually showing red again. It's not showing orange, showing that all the testing that we did on the beam has what expired, but the columns are still okay because we didn't touch column. But if I touch this column now again, that is filling here, and then increase the size or something, and then say okay, well, let's do it now. Now for the column, it's also same thing to click on the column that is filling. Right, click on the column and then say section design, which is I think, let me see, is it? Yeah, right here. I'll click on here now. Now you can see that I'll just say okay. Yeah, just say okay, because now the thing we've done I've cancelled. I'll just say yes, continue for now, and then it will open the interface again. Now you can see that it is failing based on what U ratio, which is based on what the section is small. U ratio is above 1. Can you see that here? Is more than 1. So right now I need to do what, increase the section of the column, because even if we do design here again,
so it's failing by almost 40%, no?
Now watch now, you can see this here that says what they said. Warning, look, when I did a new design, you can see that it says section size must be what, increased. It's failing based on share. It's failing on share. Can you see that? It's failing on share design. Sorry. Okay. So you can see that if it's on share, that means that we need to increase what the section size need to be increased. Can you hear me?
Yes.
Okay. So to now increase the section size now, you need to come here.
So 30.
Under here. And then let's say let's say 250. I think let's do that one. 250 by 250, or 250 by 250, then design again now. You can see now it's not showing the bar. Yeah, it's okay, and it's showing us the bar. If it's not okay, you won't see this bar here. This bar will not show. It will not show the reinforcement. For example, when it was 225 before, let's see that again, 225 now, and 225, and then update.
Okay, I see
you can see that here now is saying warning. You won't see reinforcement. What you'll be seeing is warning. Steel bar cannot be selected. Section size is insufficient. You understand? So I'll come back here and say okay, and then increase the section. Right?
Because of the ratio, no? Still to complete
ratio. Yes, exactly. Yeah.
So can you increase? Because I see it's 2.5 and it can go up to 3%. So
okay.
No. Check the steel. Go back on where it was giving you an error.
Okay, here.
And then it says that it's ASTM 2.5, above design settings.
Okay, yeah.
So your maximum according to the ACI is 3, no?
Yeah, sure.
3%, huh?
Yeah.
Can you, and then is it possible then that you can change that, and instead of it giving you an error on 2.5, that you can increase it and tell the program, okay, it's not an error, you can go up all the way up to 3. Is that possible?
Yeah, I think so. Yeah, let me, yeah.
Because I've done it with the other softwares where we increase the level, the tolerance, and then it doesn't flag it as an error, no?
Yes. Let me see that. It's possible. Let me open that again. So I'll open this now and then close this here. Then come to settings, under settings here, and then come to column here. Then design, rebar. Let me see section methods. If I to open, then containment of, let me see that. Not this one. Or let me see this. Now, let me see. Link. Not this one. Match. Not this. Let me see again. The link. I want to see where that can be found. 2.5. Let me see. Cylinder design. Yeah. Okay. Thing is here. Yes, T ratio is here. So to put 3, minimum to be, should I say minimum 3?
3.
Then here, 3, 2. Let me just put 3. Moment, I think that's okay. Then this is for war. Let me just ignore that. And then say update first. Save. Let me see now. Back to here again. I click here. Just say okay. Then design now. It's still the same thing. It's giving me same thing.
Okay. All right.
Okay.
You have to increase the size then.
Yeah, it's the same thing. Let me see.
The 300. No.
Yeah, it's still the same thing. So just to increase the size. So let me say 300. And although we can still have rectangular column instead of
rectangular. Okay.
So just say update and then send again. Okay, now I think we need to now turn it. Let's turn the rectangular. Maybe it's carrying the load on one side. Let me change to 5 now, and then 300, 600. Let me see. Then design this. Okay, no, it's still same thing. That means we can take
it's 300 by 300.
That would be
300 by 300.
Okay, 300 by 300. That's okay. Then update and then design again. You can see this now. It's not given that. Let me see.
Is it because share it would be the links themselves?
Let me change that into 0, 0, 0. Then update. Save that. Save. Okay. Then back to here. Section design. Okay, that. Then.
But if it's share, isn't it the links?
Yes. It's links. So let me come back again. Let me say 300 again. 300. Then update. Design. Okay, I think it's okay now. Yeah, it's okay. I think it should be that value that we added. So we come here now. Now it's okay. So if you take rectangular footing, let's say rectangular.
Okay, 225.
This will be 225. 225 now updates. Design. Yeah, it's okay. You can see that.
Okay, all right.
So I'll say okay now, and then you can see the UH now is less than 1, and all that. They will now come now, and then can say okay, just to view the detail elevation drawing, you can come here and view that. Just for they're asking if it's for all the story. Okay, let's just say okay, all the story, and then just give you a sample of what you to see. Okay.
So this does this already take into consideration the length of the bar where you actually will be splicing it? So you could control where the program splices the bar, no? Because you have a 10 meter but 39 divided by 3.28. 11 or 12 meters, no? I'm not so sure what is that. Some programs you can say, you can specify what is the length of the rebar. For us, it's 40 feet, no?
Okay. Okay. Like you mean
12 meters, no?
Okay, yeah. Yes. Like even now here is maximum is 12 meters. Yes, you can do that.
And then it can tell you where do you want the rebar to be spliced, no?
Yes.
Because remember that if you go with 10, 15, 20-story buildings, you'll have to splice it and you don't want to splice all of them at the same level, no? Because
okay.
then you'd end up with a weak
Yes.
level. So you'd have to alternate, no?
Yes. Yes, you can do that. So you can come here, close this one now. Let me say okay on this. Then you can come here now. You can see that now it is now okay. It's okay.
Right. Yes.
You can come here now under this still under these settings here. I think I've seen that for Beam before. Let me just go for Beam. I've seen that. Yeah, I've seen it for like Beam before. Let me go for Beam parameters. Yeah, you can see it here. Steel bar cutting length. You say 12 meters. Yeah, so I think Coulomb have that.
Because in some areas they don't sell the rebar the 12 meters, and so they have it less, and then it's but also like for example with the column itself, there is like the footing options because of the development length that you have, no? So so say for example with this is already contemplating development lengths.
Yeah.
For beams. Okay, see like for example that one, no? So if you look at the footing itself, the feet, the DP.
Yeah.
That DP, yes. So I'm looking at the footing or the DP, the coefficient now, which is the foundation penetration depth.
Okay.
The thing is that if you don't control that depth, when you design, sometimes the programs they want to give you huge footings because of so you can control with what they start, you know. So I usually place the footing to 250. So for it to start at 250 so that I can control what the program shoots out, no? And then same thing. So in this one, it's interesting. That's the kicker's depth. And when I haven't really adjusted this, especially with the other program that I use, CPE, it tended to give me wider strip footings or individual pads because it doesn't really start with any development length. It chooses a development length, no? But I can tell it with what it starts, no?
Yeah.
So those are the things, but I'm seeing that it has the rebar control, the bob controls, and the development lengths, and so where you can actually lap it, no? So the lapping on the columns, say for example on the other side, on that one, not just yes. So it's where you control where the program, because depending on how you build, you would want for it to do certain things, no? Where it positions the beams and the columns. So it's
sure.
That's good, no? All right, excellent. Thanks.
Okay. Okay, so these are where I can do any settings along this place. So you can see the members of each of them for column, for beam, for slab and anything, and for footing foundation. They all have that.
You know, for the beams, Justice, the program itself, the other one that I use allows you to decide that there is no splicing is going to be done. The splicing is only going to be done over the columns themselves, so that you don't have a. So let me see. It has some parameters there, some drawings.
Some drawings, okay.
Yeah, let me see the other one. Yeah, no, this one. Okay, so here, use links.
This for the links. So
Yes, for the links, yes. For telling maybe.
Yeah.
Okay, here, see, right there. So it's allowing, it's telling you where you would want the
wrapping.
the reinforced toe. So if it designs and meets like the 12, it would automatically cut and just do splicing over columns, so that it allows, because like that you don't have to do the farted D, no, the farted diameters and what's not, no.
Yes.
Lapping, no?
Yes.
So this is interesting, yeah. But it's good. I see that it has the controls. No?
Yeah. Okay, so the same thing now that. Okay, then this is for the bending, and I want it to like bend. You know that?
Yes, that's right. That's for like the downturns, no? Downturn.
Exactly. Yeah. Okay, so this is for all of our settings. I know that. Then close, cancel this. Okay, so now that we have touched this column now, and it's okay. But I think there's still one that is failing here. One is failing too. But this how to check for column that is failing, and then correct it by coming here, some design, and then then choose the actual size. Check what is failing. You can see it here based on the U ratio. I think almost the same size. We still pass this one, so we choose then 300 by 225 before. Then update. Let me see how you're gonna face. Okay, let me just see that. Then design. Okay, then okay, that's okay now. That's okay. Then okay, that's okay. Yeah, so this is now okay now. You can see that it's okay. Then the other one now, which is this other one here. Click on these two, right click here, session design, and then okay, that's.
And you would recommend that you place a column on the strong axis against the weak axis of the building, no?
Yes.
Yeah, so I see that you're positioning the column on a strong axis where the building itself is on the weak axis. No?
So this other one too. I'll come here. 300. Though this one can be a square, but let me just do that first and see. This is okay. This is okay. Then okay, that. Then click outside now. You can see that.
Yeah.
Okay. So now we have done for all the columns. Now that they have known the sizes that they are okay, we can now choose to run a new thing again for this. Yeah, for this not to show expired again. Understand? To run a new design and for now move into our foundation. But note, it is best you check all the beams. For the columns, you can do the ones that just failed. But for the beams, it is best to check all of them, even if they don't fail. Because most times, this sort of can end up giving you, for example, it can give you a bigger size of bar, rebar. You understand? When you can use a smaller size like part. For example, if let me open this one now. This beam now that is added. Let me just open. Let me say I want to open this beam now to check what is happening to this beam. I open this beam now, then session design, and they just say okay, and then so you can most times so now you can see that here is giving me 20 diameter D20. You can see that, although based on the span, I see that, but I can choose to control this now using steel. I can still use D16. Let me see if I do that. So decrease this now to 16. Is unfailing here. Then increase to 4 numbers. I can see that it is passing.
Yeah, but you would want all of them to be the same, no?
Exactly.
You have your cage reinforcement, and then you have your additional reinforcement, no?
Exactly. So just to avoid any issue at site, understand? Just to have the same reinforcement size or something, understand? So you can choose to check all of them It's just to be sure that you don't have different diameter of bar on just one beam. You understand? So you can just to control that by checking all of them and now say, okay, now on this, okay, that's fine. So that's how to do that. So that's how to check for your so once you've made sure that all your sizes are okay, you can now run the final design. All right, just to make sure that here is ticked good.
Oh,
That's
okay.
exactly. It's because right now you can see that it has cancelled because of the changes that we made. Exactly. So once you've done that now, then come back here, do this here. Check this, check this, then launch the design. So once you've done that now, then that should be okay. Then next time we meet to deal on the, I think tomorrow.
Yes,
we can deal on the foundation.
Foundation.
Yeah, but before then, we first of all design for the slab.
Mhm.
Understand?
Okay,
For the
thank
slab.
you so much.
Okay, yeah, that's fine. Okay.
You're really good. Thanks, Justice. I enjoyed the classroom. The class was excellent, very well put together, very clear. No, so I enjoy it. No.
Oh yeah, thank you. Okay.
You're gonna send me. You're
Yeah,
gonna send me that video, no?
Yes. Yeah,
Okay,
the link. Then I'll send you also. I don't know. Do you have any CAD file that to work with?
What's that?
Any drawing? Do you have any drawing to work with? Any CAD file to work with?
Okay.
To practice.
That I'm working with?
No, like I'm if you have any CAD file that you're going to practice with for what you have done.
Yes. I'll practice. I'll practice with one that I'm doing.
Oh, okay. That's
I'll
fine.
practice with it, and then I'll see how far I can get.
Okay,
It's almost similar to this one, no? The one thing that I'm also doing is that I'm checking to see how I can. So I'll do the one with AutoCAD, then I'll bring it in, then I'll see how it plays with ArchiCAD, and then see how I can create a streamline ArchiCAD. So just like how you showed me that it can't model the so what I'm doing now is that I'm modeling only the beams and columns, and I'm inserting the slabs in Protastructure, no? So it seems to work. So, but I wasn't able to get this far as how you explained it to me, no, because I didn't understand how to put the foundation and the first floor level. So all these are things that I enjoyed. I see that I'll try to model it, and then I'm going to see how I can add then the loads myself. But it's a similar building like this, no?
Okay, that's fine. That's okay. That's fine. Okay, that's fine. So we meet again tomorrow for the foundation and for the slab design.
Amen.
Okay,
All right. Okay. All right. Well, you have a good evening,
you too.
Justice, and we'll meet tomorrow, no? Thanks.
Okay, yeah, that's fine. Okay, yeah. Okay. Okay, so can you hear me?
Yes, I can.
Okay, that's fine. Okay, so were you able to try your hands on that?
Excuse me?
Yeah, I was asking if you're able to try your hands on what we did yesterday.
If I tried it, yes, I'm doing my own thing. I was waiting for you to send me the
link, right?
class. So
yeah.
if you can do that, I would appreciate it. And also if we can also like keep the time, because what happens is that just like how you have other things, I am also
doing.
I need to go here, go there so if we can agree like 8:30 your time, 1:30 my time, and we kind of stick to the hour half an hour, no? So hour and a half, no? So that way we can get stuff. I can organize my day, no?
Okay.
I would really appreciate it. And also if you can send me the video from the last class, so I can look at them.
Okay, okay. I will do that. Yes.
Thank you.
Okay, do that. Okay. So on today's training, it will be on the slab design and then the pie foundation. I know that.
Okay.
So with this now, once you're done with your building design and everything, you can see that your slab is still showing
White.
white,
Not
which
designed.
means not designed. Yes, I know that. So we now have to come back to our plan view here and then design for the slab. And how do we do that? You have to go to modeling tab here. Then you see slab strip.
Slabs.
Slab strip. Although before the slab strip, you can come to your slab and set your maximum spacing that you
Okay.
want. So I'm going to settings
The
now.
settings.
Yes, come to slab here. Then come to this place. Weber. Yeah, you can see it here. Maximum spacing 300. I can say, okay, I want to use 200 as maximum spacing, and then minimum spacing. Let me say I want to use 125. You understand? So you can set all this, and then minimum bar size D10. That's 10 to 10. I know that. Okay. So by doing that now, also let me see. Also come here to concrete cover. You can see here 25. And that's okay. So that's all the sets.
Is it? Okay. Yeah.
Yeah, that's all the sets. Then now I can just click on this print steel bar total length if you want that. Then you can click on save. Okay. Then save again. So with that now, we can now come to modeling here. Then slab strip here. Now under slab strip, yeah, you can see that we have X direction and Y direction. So the X direction is going what? Is going this way, horizontally, and the Y direction is going the vertical direction.
Vertical, yeah.
Yes. So with that now, I'll begin with the X direction. Then I have to come here that says slab type. I'll just make sure I am on this first one here, analytical step. Strip. I'll click that first one. And then, most importantly, these boundary conditions. Knowing that we might have a cantilever at the boundary, all right? Let me say a cantilever or just a slab. And then we'll have just beam as the boundary. So in this case now, if I want to cut or detail a slab through this panel, through the X direction here, I have a boundary here to be what? Beam to beam boundary. Are you there?
Yes, yes.
Okay. So right now I have beam to beam boundary. So with that now, this middle one here, these are beam to beam boundary, all right? Okay. So I see they have at start and at end. So if my beam to beam boundary, if my boundary now is beam to beam, I will come and choose this and this. This one here is if we have cantilever slab starting and cantilever slab ending, you
cantilever, no?
Yeah, you can pick these options. Or you might have beam here and then ending should be cantilever. You pick start beam at end cantilever. Understand? Or at start cantilever at end beam. Okay. Then this other one here is slab. For example, now I want to detail just from this panel here, from this, let me say from here to here. Right? Yeah, since I have slab here already, and I have slab here already, but I want to just detail only this, just this one. So I will say slab to slab. I see that this is slab to slab, like slab ending and slab starting and slab ending.
Yes.
Okay. So in this case now we have beam start
beam and beam
end. Yeah. So I'll come here and click beam to beam end, and then with that now I'll then come. I'm on the X direction. I'll then come. Just take your hands after the beam, not too far. Then click, and then hold your control key to keep the line straight, and then cut through the panel, and again pass the beam again a bit, and then click again. Okay, then now you can be able to see that now. You can see here, it's showing you 20 D10 and 200 spacing T top.
Yes, sir.
Yeah, so you can see that, right?
Yes.
Okay, so I'll do the same thing now for the next one again. So I want to cut now from here again all the way down here. Again, since I've already cut through this other panel, I'll cut from here to here or from here to here. So right now, my start becomes beam and my end. Okay, let me see. Okay, I want to cut from here now to this other place. So it's still beam to beam. So I'll cut from here to here. Okay, so right now we are done with the X direction. I'll then change to Y direction. Again, the Y direction is still beam to beam, so I will still be on that beam to beam, and I'll cut again from here to here. Okay, I have that now. Again, I'll move to the next panel. Now, I want to cut through this panel. Then later, I'll now come and cut. Okay, let me cut this one now. So I want to cut this now, beam to slab. So I'll come here, change the end to slab. I'll come here, click on this, and then pass through the slab, and then click here. So I have that now.
Okay.
I'll now change beam to beam, and I'll cut from here all the way down here. Okay, and again, from here all the way down here. And again, the last one now, from here all the way down here. Correct. So right now, had it been the depth is not sufficient, while you're cutting, it will show you a warning that either the depth of the slab of that panel you're cutting through is not sufficient. Although now we are done cutting the whole slab now, slab strip, you can then choose to do what close, and then go and look at the slab design reports by coming to under this place now, under the strip here. I'll click on this strip now, right click, and okay, under the slab, sorry, slab here, click on the slab, right click here, and then you see here slab analysis and design. I'll click on this now, and then I can choose to generate the reports. You can see first everything is okay here, else you'll be seeing failure. You can see the spacings of each of the panels and all that. But you can see generate this report from here by clicking here, design reports, and then just hold on for a while. It doesn't take much time. So, okay, I think it's already done. Correct. So you can see the slab design report now for each of the panels.
Okay.
Okay, yeah. So I can choose to do PDF or not, or Word. But let me just cancel that. Then I'll now, if you now come back to this 3D view now, you can see that all your slabs now, they're now green. Can you see that?
Green.
Exactly. So right now we have done the slab design and all that. Then let's now move to the foundation, to what we have now. So we have checked for let me say that we have checked for everything. We have checked for the beams, for the columns, and for the slab. So we are done with we are done with the whole superstructure. We're now entering into the substructure design, which is the foundation design. So right now we go back. I'll come back from this design interface and go to model interface, which is this one here, none. I'll click on OK. So on this now, I'll go back to story 1 and then go and make story 0 active. Story 0 becomes the foundation level. So I'll make story 0 active, click on it, and then you see only our column points and all that. Okay. So
do that again.
Okay, so right now I said why we are on the story 1, which is the first story 1, to now begin the foundation design. Come to story 0 here and double click on it, double click. So I'll click on this place and double click. Understand? Or
yes,
or while I'm on story 1 here, I'll click on story 0 and then right click and you see select story. All right, I'll now select the story here. You see the same thing. And now I'll now be on story 0. Now, on story 0, all you see is just a column point. Because right now, you have not yet done any foundation design and all that. Okay. Now, you say that in your country, you use more of mini pie foundation, right? Mini pies.
Yes,
Okay, so with that now, we will start with a pie foundation. Okay, so to begin a pie foundation, you have to go and make some kind of settings first. It's still under setting center here. I'll click on this place now, so setting center, and then I'll click on foundation. You can see it here, foundation. Okay, so on this foundation now, you'll be able to see your soil unit weights.
okay.
And that you have to put that. Then you can see, based on code, you can see your soil strength factor, allowable soil stress factor 1.25. Then you can see here that says allowable stress of soil. That's the bearing capacity of the soil, right?
Yes.
Okay, yeah. Sorry. Okay, that's fine. Then on this place now, sorry, let me call you back. I'm in a meeting. Yeah. Okay, there. So on this place now, you put your soil bearing capacity here. So although before you must begin your foundation design, you must have gotten a soil bearing capacity. So like you must have gotten a soil report, all right, for that location or for that site. Maybe I want to construct that building. You must have gotten a soil report and all that. So that way you see most of this information.
Okay, I'll send
Yes,
you. I'm sending you a soil report.
Okay.
Which I promised to send you.
Okay,
so I already sent it to you so that you could. You wanna?
Okay, let me see that. Okay, let me open that up. I don't know if you can send to my email, so I can just open
I sent it there to your WhatsApp.
Oh, okay. Let me just see that. Okay, let me open that up. Okay, let me see. It's coming up. It's coming up. Okay, let me go up now. Terra engineering. Okay. See that? Okay. Sorry. You see. Okay. Okay, I think from this place here, they said allowable soil is 200. I don't know if you can see that. They have ultimate 600, then allowable bearing capacity to be 200, which is 4,000 PSF. Then settlement, they say is 0.65 centimeter. Then, okay, yeah. Then footing pressure 200 kPa. So the bearing capacity here, which I'm seeing here, allowable soil stress, is 200 kilonewton per meter square. That's 200 kPa. That's 4,000 PSF.
So 4,100 PSF.
Yeah, is equal to 200 kPa. That's 200 kilonewton per meter square. Can you see that?
Yes.
Okay, that's what we already have here as a default. But had it been it was changed, maybe just putting the value here and all that.
Okay.
Then you're now seeing here that says pi safe load factor. Here is 1.25. Let me see if the soil report gave their own pi safe working load factor. Let me see. Well, I know that actually comes from, but let me see if they have their own from based on the soil reports. Let me see. Okay.
It probably would be the settlement based on the putting pressure, no?
Is it what?
No, I don't think it's listed here, you know.
Yeah, it's not here. Yeah, it's majorly from code or from design. Although most times they can be able to list it too on the soil reports.
File save.
Yeah, but if they don't have that, then we'll
Okay.
take this 1.25. Then what again? Now we'll leave this one here. This one is if you're doing, you can see that says ignore safe bearing capacity for pile foundation. This is if you're designing for if you're doing a raft pile, like a pile draft and all that, a pile draft, then there's an option where you can choose to ignore this. And
File raft, you said?
Yes, if you're doing for a pile draft.
That's like what?
You say what?
That's like what?
I don't know. Do you know a pile draft foundation?
I'm gonna Google it and see what is it that you're pile raft, is it, no?
Yes, pile raft foundation. Where you have a slab raft, that's a mat foundation, then having a pile underneath. Pile draft.
Oh, okay.
Yeah. So when you have that, you can choose to ignore this and all that.
Yes. All right.
Yeah. Then now on this place now that says soil vertical surcharge coefficient and all that. If you click on this now, you click on this, you will see several surcharge coefficients and all that.
Okay, all right.
Yeah. But
so where did you go for that one?
You can see it here. You can see it here. They said surcharge coefficient. If I click on this, select here.
Well, this would be for like an end bearing.
Yes. So you can see several surcharge coefficient and all that.
Okay. All right. So let me answer this question. How would you understand the pile capacity? Say for example, I know pile capacity. What we do here is that we only look at the so we disregard the soil because it's in where I'm at. We can do two things, no? So we have two types of soil that we have. So we have a clay, stiff clay, which has no bedrock.
Okay.
And so we have to do friction piles. And then the other one is where we have coastal plains, which are a lot of swamp. So it's really silty, sandy clay or silt, where you don't really have any bearing capacity. So what we do, we drive these piles on the ground, 30, 40 feet, and then so we basically, they're end bearing, so they're directly on bedrock, no? And this kind of bedrock is an old weather limestone.
Okay.
Yep.
Okay. So basically, based on surcharge coefficient and all that, so most times it's very difficult to pick the exact like the right value. But if you go to there's a textbook called Joseph Boyce. I don't know if you know about it. Joseph Boyce. Do you know about it?
What's that?
I said there's a textbook called Joseph Boyce. A soil foundation textbook called Joseph Boyce. Do you know about it?
Okay. So it will be loose sand, no?
Yes, but what I'm saying is that you have to pick the correct value.
Okay.
You understand? That and it's most times it's very difficult to pick the exact value because then you can just come and then pick the value for that. Here is saying 20,000. Here is saying.
Yes, but this one would be for what? This one would be for the end bearing. Like if this one you select like the like the bearing capacity, or because if not, then we can say rock, no, because I'm putting the piles directly on rock.
Okay, rock. Okay, so see what we'll do basically. I know that if you are sure of the value you are going to pick here, and you're sure of the value of the soil, you know that, then you can then pick the right one here. But I always advise, knowing that it's very difficult to pick this correctly, if you check, if you look at the like the older versions of this software, they normally give a reference table where they got these values from, and that's from the textbook Joseph Boyce and all that.
So let me ask you this question
now. But just to now, if you do now,
just one question.
Okay, let me hear you.
All right, so we have our soil here. We are going to be putting our house onto this, no? So what we do, we drive piles,
okay,
all the way down, almost sometimes 10, 15, sometimes 20 meters.
Yeah.
20 meters down to the bedrock.
Okay.
So we drive so all this soil here, we disregard.
Okay.
And we only, so we have piles that are 25 by 25. We have piles that are right now 30.
You mean in length?
No, in the
area.
area. So we have a pile that might be the cross section, no? Is that 25 by 25 no?
Okay.
And that pile has a bearing capacity of 30 tons.
Okay.
And then we have the next one, which is 30 by 30. And that has, or 300, no? 300 by 300 and 250 by 250, which has a bearing capacity of 60. And then we have a third one, which these are the commercial ones I'm telling you, which is 36 by 36, which has a bearing capacity of 90 tons, no?
Okay.
So we have, so these are the cross-sectional areas that we have. So what happens is this, that we actually do the pile caps, you know.
Yes, sure.
We do pile caps over these piles, and that's how we would then transfer the load down to the ground, no? To the limestone.
Yeah.
So the limestone capacity has a capacity of, I need to check it, but
Then also, I think from the soil reports here, they did to a depth of 4.8 meters. So is and at that place, they found a silty sand. There's a sandy.
But this is a different. This is for a different place.
Okay.
I'm gonna try and see if I can find another one, which would be for.
Okay, for
where I'm telling you.
Okay. Okay. Let's see. 4.8 meters. So are you seeing that?
Hey,
Yeah, I'm just asking.
I'm sending you one. So
Okay.
okay. Okay, you should have it.
Okay, let me see.
So this was a report that was done here where I'm telling you that we.
Okay.
So if you look at the
Okay.
soil report that was done,
Okay, let me see. So this for a bungalow.
well, this was for a church that they were,
Okay, church.
yeah, for a
Okay.
church. So the bedrock is at, in this case, it's like 10, almost 10 meters, 9 meters.
Yeah, let me see. Okay, yeah, see that. Okay. Yeah, and the soil is very bad. Soil is like
If
a
you look at the conclusions on recommendations, no, it says that the bedrock is about 20 feet to 23 feet below, and the allowable presumable bearing
what
values
what page is that? What page is that?
8.
Okay, page 8, okay. Let me see. Okay, yeah, conclusion, yeah.
So it range
20,
between, so
yeah, 20 feet of soft soil means
which is
yeah,
really
bearing capacity. Let me see. Okay, from yeah, call in the structure found okay on end bearing price. The proposed structure to be built on the
so
property.
if you notice it's 13 tons per square feet, no?
Yeah, per square feet. Okay. Then with the range of this. Okay, so that will be what in the okay. So that's the reliable pressure. So
So that we would put where?
you say what?
So for the piles, that is the bearing capacity for the weather limestone that we have.
Okay. So now this is the weight on the pile. What think so?
So
Okay, no. Okay, no. I'm seeing 7 to 13 tons per square feet. 78 to per square meter per meter square. The use of flat foundation is not recommended for any intended due to the depth of very short. Okay. I mean, this the soil has a very large settlement.
yes.
Okay. Okay, I can't really read. I can't really read all this. I can't really read
let me send you another document,
okay.
which would be for the type of files that we so that you can see what is it that we're dealing with, no? So
Oh, okay.
so that you can. So I already sent it to your WhatsApp.
Okay, let me see. Okay, let me see. Okay, let me see. Find the equipment and information. Okay, that means in this case, let me see. Find good condition before proceeding to the next slide. Okay.
I'm sending you some information also on the files themselves, so that you can have an idea of what is it that we how we build these files commercially, no? So
Okay.
if you open this image I sent you,
Okay, let me see. Create stress fly.
so the size is the squares, no? So 4, 10, 12, 14, and 18, and it gives you like the service load that they recommend, no? So 90,
Okay.
I mean 98, 129, 175, and 290, no?
Okay. Okay. So let me
Tons
see.
per foot. But the problem is that you have your weather limestone um, only has a bearing capacity of um, well, from the other report, no? I sent you a,
Yes.
so the previous report was saying that on page 8 that the bearing capacity more or less is only
7 tons per
146 tons,
okay,
so 13 per square foot, 146 per meter square. So you start to look at, even though the piles themselves have a capacity, um,
Yeah.
the rock itself only
So
has.
yeah. So basically, based on that, this that one falls under 14. That 14, yeah. That's the size, 14 inch.
Yes,
Yeah, because that one was saying 13, I think 13 tons something, 13 tons per square foot. So okay, that was under. Let me see that. Reliable load. Okay. So that was a friend. Okay, that church home. Are you saying that the load is 13 tons per square foot?
Uh-huh.
Then on this place now, they are saying that allowable concentric service load tons per tons in tons. They have 86, 89, 129, and all that. Although this links to the sizes.
Yes.
Yes. So I think that falls between 12 and 14. So either first of all try 12, then if it doesn't work well, then try 14.
Yes. So if you see each pile, one pile can bear, say, 90 tons, no?
Yes, I can see that.
So you, whenever you're designing the piles, and you can say, all right, you know what? We don't go with those numbers. We go with far less than that. So we usually would say 90 bearing capacity. We usually bring it down like 30% less, no?
Okay.
So
Okay.
89 times 0.7, then
Yeah.
but the thing is that we say 60, and the next one we usually just trim it 30% off it, no?
Yeah.
But anyway,
Okay.
just so that
So
you can know this, no?
yeah. So in this place now, based on the first soil report that was given, we say they have silty sand, which falls under loose sand. Loose sand.
Okay, loose sand.
So that now we're going to choose upper limit 20.
Okay.
Yeah, 20,000 kilonewton per meter cube. Then, sorry. Then we move to, I think that's all for settings here. These other ones are for link concrete. I think link concrete, you can either use 75 or 100, but in my country here, we use 50 as the minimum. So,
Okay.
but based on ACI, they say 75 and all that. So either 75 or 100 for link concrete. Yeah, so let me say 75. Then extension, same thing, 75 or 100. Then we can leave this one because we are not dealing with footing design, so we can leave this one here.
Well, what is that? What is the strip footing cantilever length?
Now, yeah, you know that if you have a strip, I don't know if you know about strip foundation. Let me show you that. For strip foundation now, let me show you that. Strip. Sorry, let me just say why strip foundation.
I know.
Okay.
I know the strip foundation and.
Yeah, so there used to be, you can have a cantilever, like the beam might come out from the from the grid line. So that they're not asking you that length of the cantilever that the beam will come out from. Let me just show things here.
So it's
okay.
So the reality is they tell you, like, if you want to, like, 1 meter wide true foundation, no?
No. What I'm telling you is to know the distance. That's what they're asking. That, okay, for example, this one here. Let me just download this. So you can be able to see this now, having a like the beam comes out from the column. So let me open that now. Correct. So now they're asking you, what is this? Sorry, what is this? Still opening. Okay. So now they're asking you. It's coming up. Although you can still choose to change it if you don't want that. Okay, correct. So they're asking you now, what's this distance? If you can see this here, you can see the beam comes out. That's the ground beam. Comes out from the column a bit. So they're asking you, what's this distance here? Can you see my screen?
No, not yet.
Can you see my screen?
No, not yet.
Not yet.
Okay, yes, now. Yes.
All right, so you can see the beam, this ground beam comes out from the column. You can see that. So they're asking you, what's this distance? What's this distance? That's what they're asking. Exactly. So it can be 1 meter or 1.5 or 2 meters. So the more they cantilever length, the wider the footing. The wider this footing that you're seeing here will be wider. The footing under the beam will be wider. Yeah, so that's what they're asking.
Okay, all right. So that's an arbitrary point. You can decide.
Yes, but yes, you can start with 1,000 as the as your lowest minimum. Although most people go with 500 too. You still okay? Yeah. So that's what that is saying.
All right. Okay.
Okay. So now that was it. But now we are not dealing with that yet because we are doing a pi foundation. So I'll just leave this. You understand? I'll leave that. So because this is a general foundation setting, both for mat foundation, for pad, for pi, and everything. So right now, we are only going to set the ones that have to deal with pi. You understand? That's what we have just done. So every other ones here, we'll just now this is for a pad footing. You can have square or rectangular. So they're asking you what's the default. Default. So we are not dealing with this, but let me just say rectangular. So and square. Then, sorry, are you with me?
Yes.
Okay. Now, on this other side, they're asking you minimum, but these other ones too is if you're designing for a pad footing, you can make these settings here. I know that. But we are dealing with pi foundation, so we have to ignore these ones. Then you can see a minimum reinforcement. This is for general, both for pi, and everything. So now here it is saying 12 minimum, and then distribution bar still 12 minimum. I think in your country, for like pi foundation, you can use 12 at least. Minimum should be 16 based on the length it's going. What do you guys use in your country as your minimum?
The what? Minimum what?
Minimum steel, like minimum bar size.
Minimum pile size?
No, bar, like rebar.
Bar.
Yeah, reinforcement for like
for,
pi foundation.
for the pile cap?
For pi foundation.
For the pile. We use
Yes,
cables. That's so if you look at the last one that I sent you, it shows you the design for the pile.
Okay. So because I think that one you sent me last was like a pre-stressed pi, right? It's a pre-stressed.
That's what we do. But the thing is that we can use 5/8. But that's what we usually use, no? 5/8, which is 16, I think, if I'm not mistaken.
16, yeah, 16 is a minimum actually, both in my country. Okay. So then
right now I'm checking how much 5/8 is, no? 5/8 convert to mm, no?
Okay.
So 5/8 metric 15.88.
Okay. So that should be 16 approximately.
16, yeah, 16.
Okay. So then now we then move to once we're done with this now, we are done with these settings here. We can then move to, let me say, pi cap here. So now we are under this general foundation setting. So we now move to pi cap settings.
Okay.
Now they're asking you type of shaft type. That will have circular, will have square.
Okay, right now.
So what is common in the country? Circular, right?
Square, yeah, that like the ones I showed you.
Okay, square. Okay. Then they're asking now.
I'm seeing a different screen. I'm not seeing the Prota screen.
Are you serious? Let me see. Oh, let me move this. So what are you seeing now? Let me know.
No, still yet. I'm seeing the strip foundation.
Okay, let me just reshare again. Okay, reshare again. Okay, so check now again. Check in.
Nothing yet.
Let me wait for maybe network. Let me just wait for a while.
Mhm.
Please check now again. Let me know.
Nothing yet.
Nothing yet. That's bad. No. What? Just check if you're seeing a white background or something. Because
Yeah,
right now,
I'm just seeing your screen. You.
oh, let me see. Let me see again. Let me share again, but I'll share based on the interface now. Let me just see. Click it again.
No. Okay, yeah. It came and it went.
Okay. Let me see again. So let me know once you see that, because I've shared already.
Okay, well, nothing as yet, but what we could do, if you while we wait for it to load,
Let me
um,
see.
we can talk about the. Okay, now
Hold
it's
on, let me
loaded.
see. Hold on, let me see. Okay, check now again.
And nothing as yet, no. I think you left.
Nothing else. Oh, let me see again.
Mm,
Hold on, let me see. I don't know why it's not in that way.
nada.
Okay, just check. Let me know.
No, nothing as yet. So
Okay.
one of the things that kind of bugs me in terms of um, these is that the pile itself has a bearing capacity of say 90 tons per square foot, no?
Okay.
But if we have a 10 by 10, that's 100, and if it's saying so at a 10, which would be 25 or 250 mm by 250 mm, has a
Yeah.
load bearing capacity of 98 tons, no?
Yeah.
Uh-huh. So the problem, do you know if Prota can analyze a pile based on length? Because I know the shorter the pile, the more bearing capacity it might have. Say this one, if you look at the concept, it says that it has a it's done with 6,000 psi, no?
Yes.
So I'm not so sure if you well I still can't see your screen. I'm not so sure what's happening, no?
I just see you.
That's why I'm trying to use the time and pick your brains on this.
Let me.
So if you can you go to your to your WhatsApp and check what I was telling you with the
Okay.
design, no? So
That's
there's a
the one you
there's
sent. Is it the first one or the second one?
what's that?
The one you sent, the second file you sent, or the first file?
The one that says pre-stress piles, no?
Okay. Yeah.
So it talks about the piles being designed to conform to the PCI code.
Yeah.
Um, I'm not so sure if you're familiar with that code.
No. I'm not known with that code.
Okay. And so this one, if you notice, it's British standards, no? So there's the characteristic strength of concrete at 28 days is 7,000 uh, nothing as yet just
Yeah,
this. No, I'm not. Do you want to end this and
okay,
I
okay.
can
Okay.
open.
Okay, see what you do. Just go off and then come again. Go and then come back again. Yeah. Because I believe it might be his network that's having this issue. So I don't know, maybe I think so. So let me just share again now.
Okay.
So can you see my screen now?
No, not as yet. And I'm not seeing. I used to see you. I used to see your face, but now I can't. I just see like the like your presentation screen. No.
Let me do something. Okay, let me see then. Okay. So check now again.
Le pedí yo a Rex si nos podía dar los 10 bolsas de cemento
So
para que Jesús lo vaya a buscar ahí. Hace confirm si lo aceptó. Si no, pues nothing yet.
check, let me see again now. Can you check now again? Let me just see.
Can you see my screen? Can you see me on?
Yes. Yeah, I can see you.
Yeah,
Can you see me now?
that's I used to be able to see you, but now I only see your presentation screen.
Okay, hold on. Let me see.
Chimka.
Yeah, okay, hold
Just
on.
says Chimka.
Let me
Mwokan.
okay. So can you see me now?
Your presentation screen. Not as yet.
Okay.
Is Justice? Okay, now I see you.
Okay, that's fine. Then check if you can see my screen now too.
Okay.
I think so. Can you see my screen now?
Nope.
Not yet.
No. I was able to see you a little while ago, but now I can't see you.
Watch again.
No. You want me to send you a Zoom link?
But okay. But can you see my screen now? I don't know.
No, not yet.
Okay. You can send me a Zoom link.
Okay, let me see a Zoom.
Okay, that's fine then. That's okay. Yeah. Okay. Okay, let me carry that. There's only send. Okay, let me see that. Uh, okay. Yes, I'm like joining. I'm joining. I don't know if you can see me. Hello. 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 Yeah, I can hear you. Can you hear me? Can you hear me? Okay, that's fine. Okay, so um, so can you see my screen now? Okay, that's fine. So back to the place where we were before, which is under the settings center, and then now we are on the foundation settings here, foundation setting, and we are done with this general. We then move to pi caps. Now for the settings now, you say that what you use is shaft type as square pies. And I'm not saying that penetration here, either you use not yet 100, okay, 100. Then the pie size, I think 3 something. The pie size, that's 250. Okay. Then we then move to ultimate compression capacity. That's yeah, that should be what's included anything. That should be 6. I think 600. Let me see. Comes to anything. Comes to okay. This is kilogram. Is it what? Okay, so you say 60, right? That's 5 something. So let me say this. Okay. Okay, so yes, yeah, okay, 600. The ultimate tension, we can leave it at that. We don't really have tension that much. Then your default pie length, 9 meters. Okay. Then spacing for the spacing factor, either use 3.0 or 2.5 for spacing factor for the pie spacing factor. Yeah, so I just leave at 2.5. Then distance to face, either use 100, 150, or sorry, 150, 200, 250, or 300. Now use 300 if the pie cap is not resting directly on the ground. That's when you use I think pie diameter half, like pi diameter over 2 plus 100. Yeah, you can use that. But if the pie is resting directly on the ground, you can use that 150, 200, or 100 as the value here. But this is just the like the distance between the face of the pie and the face of the pie cap. Yeah, if it is too close, it will like crack the pie cap at the edge. Exactly. So we can leave, we can say okay, 150 and then 150. Then this is the pie cap depth, which invariably is has a formula actually. But let me hear. What do you say? Yes, it has a formula. Pie cap depth. What do you say? Yes, because it's actually two times the diameter plus 100. So, but let me say minimum 500, and maximum, let me say 900 or 1000. Maximum 984. 984. Yes, but yes. Okay. Okay. Yeah, yeah, sure, sure. Yeah, sure. Yeah, although this is just the maximum. So we can go higher, so in case we can have a wider range for us to pick the maximum. So we can say 1500 so that we can get to pick from there. Then number of pies, we can say minimum is 1 and the maximum we can say, because since this is a small structure, we can say 10. Yeah, it's not a big structure. Okay. Then you can leave this one as default. Then this one too as default for us to have like 3 different pile arrangements. Yeah, in a pile cap here. Then for the cover now, we can, I think 75, I don't know, is okay for your country. 75. Okay. 75 too, and then 75. Okay. Now leave everything here as default. This is just based on the report area. And then this is for costing, but you can leave that. This is for costing. And this area, I can leave this area. That's for cost. Then you now move to pi. For the area of pi, no much settings here under here. It's still now for pi, maximum steel area ratio 8%, minimum steel area ratio 0.4%. Then steel area step is this. You can leave these ones as they are. Then the pi rebar too. Pi rebar maximum spacing is 200. Minimum spacing is 100. So you can leave here too, except you want to maybe change it. But for me, I'll just leave that. Then once you've done that, you're gonna come and say okay. Then save first. Once you then save it. Now you then come to back to plan view to 0. Let me just look for that to like save. Okay, so back to plan view now, story 0. Now on this place now, we will then click on one of the one of the columns. So let me click on this column here at the center. Sorry, can you hear me? Okay, I click on one of the column here, right click on it, and then click on insert pie cap. You can see it here, insert pie cap. I'll click on that, and then wait for it to display the pie cap dialog box. Okay, it's coming up. Okay, so it's coming up. It's still coming up. Okay. Yeah, it's still loading. Okay, correct. So now you can see what we have here. Now on this now, based on the design first, you can see it gives us a number of pi for that column. For that column is 1. Depth of the pi cap is 500, and shape of the pi of the sharp pi square. Then just the same thing that was set on that area. That's what came here, and all that. Then pi spring coefficient is 100,000 kilonewton per meter square. Then if we go, then column type, I think is okay, can do that. Then if we go to the pi, okay, I want to show you, okay. What's that? You mean for the pi? Yes, yes, yes. 550 by 550. That's the yes. Hmm. Okay, yeah. Let's go there. So right now, before we go there, let's go and look at for the column load. For the column load. So you can see the column load here. It's load. Oh, okay. So this is the pie cap first, showing this. You can choose to change the pie, like the label here, to either pie cap 1, let me say PC1 or something. You can put 1 here. And all that. Okay. Then we now move to pie location. So now this is if you have like a group pie. If I click on any of them now, you can see they will show me where that pie is. You can see pie number, pie 1. Let me say I have pie 2, pie 3, pie 4. If I want to know where pie 4 is, it will just click on it and then it will tell you where that is. And yeah, then most times too,